In today's video, we're going to be building a MERN Authentication app. Here's a demo of the app. We have a login form, but first let's create a new account, and I'll use a test email. Then I'll add a password and create an account. This takes us to our dashboard where we can see our email and create date, and we also see this alert telling us to verify our email. So if we go into Resend, we should see an email here, and we see the subject is verify email address. And here's that email verification template. If I go into the plain text version, I could copy the link and just paste it back in my browser. Now our email is verified. So if we go back home, we no longer see that alert. I can also see all of my sessions. So if I go to the settings page, we see our current session here with my user agent. If I log in through another device like Postman here, I could log in and now I should see that session in my dashboard. And here it is. I can also remove sessions if I find a session that looks suspicious or I don't remember adding. So I can just get rid of that, and now that user won't have access to my account anymore. I can also reset my password. So I'll log out first and click Forgot Password. Then I need to enter my email. I'll hit Reset Password and we see email sent. So let's go back in a Resend, and here's our password reset request. This has a similar looking email, and if I go to the plain text, here's our link. So we have a verification code and an expiration date. Now if I take this link and just paste it into my browser, I get prompted with a new form. So I'll just create a new password here, and I'll hit Reset Password, and now I should be able to sign in with that new password. So that worked. Now I want to show you how the authentication works. When we log in, the server will try to validate the email and password. If those two are valid, it'll return an access token and a refresh token. Those tokens are stored in our cookies on the browser, and we can see them if we open up our console and go to the application tab. Then under cookies, on localhost, we can see our access token. Here's the JWT payload for the access token, and this is only valid for 15 minutes, so it's a short-lived token. We also have a refresh token. We just can't see it here, but it's on our browser, and that token is valid for 30 days. Every time that we make a request for a protected resource, for example, if we go to our settings page and we check the network tab, we'll see that on the request cookies here, we sent the access token. And on every request, our server is going to parse the access token and try to validate it. If it successfully verifies the token, then it assumes the user is authenticated and proceeds to handle the request. After 15 minutes, the token expires. So I'll go back to the cookies here and delete it. And watch how our app will automatically refresh the access token using the refresh token. So I'll go to the network tab and try to visit the settings page. And from the user's point of view, it looked like everything loaded in normally. However, if you look at the network tab, you'll see that the initial request for the sessions returned a 401 unauthorized error. And if we look at the response body, we see an error code of invalid access token was returned. After the front end received this error, we could see that we hit the refresh endpoint. In the request, a refresh token was passed from our cookies, and the server returned a new access token. And this token gets stored in our cookies so that when we retry the original request, which was to the sessions endpoint, we then send that new access token, and this time it's valid because it was just signed and set in our cookies from this refresh endpoint. And from the user's point of view, they had no idea that we actually refreshed their access token behind the scenes. All they saw was the sessions page load up, and they don't have to worry about signing into their account every 15 minutes when their access token expires. I've added logic on the front end that checks anytime an error is thrown from our API, if the status code is 401 and the error code is invalid access token. If those two things are true, then the front end will automatically make a request to the refresh endpoint to try to get a new access token. If the refresh endpoint returns a success, then it means that a new access token was returned in the cookies, and therefore we're good to retry the original request. But if the refresh endpoint failed with a 401, then we know the session isn't valid and we kick the user back out to the login page. We're going to use React and Chakra UI to style our front end and then Express, MongoDB, and TypeScript for our backend. We're also going to use Resend as our email service because they make it really easy to send emails. So without further ado, let's get started. Before we start writing any code, I want to go over the entire authentication flow for how this is going to work. So initially, the client is going to send a login request to the server. The server will check the credentials, and if they're valid, it'll return an access token and a refresh token. The access token will be sent with every subsequent request, but the refresh token has a path parameter set on it so that it's only sent when we hit the /refresh endpoint. And that's going to increase the security of our refresh token because it's only ever sent on this one path. So it makes it much less likely to get stolen or tampered with. So then on every subsequent request, we're going to send our access token, and the server is going to validate the access token and send back the response. After 15 minutes, our access token will expire, and our server is going to send a 401 unauthorized error. Our front end is then going to check for this specific error, and if it received this error, we're going to hit the refresh endpoint. So it's going to make a request to /refresh, but this time it's only going to send the refresh token. Then the server will try to validate this refresh token, and if it was valid, it'll return a new access token. This access token then gets stored in the cookie, and with every next request, it's going to pass that new access token. So again, the server will respond with a 200 OK. And let's say after 30 days, the refresh token expires. So the request will be made to the refresh endpoint, and the server is going to return a 401 unauthorized. So our front end will know when there's a 401 unauthorized error on the refresh endpoint, it's no longer going to retry any requests and just sign the user out. So that's the whole flow, and I have this diagram in the README. So if you go to the GitHub repo and you scroll down, I have that diagram here. So you can always refer back to the flow. So now let's get started with writing some code. All right, so to get started, I'm going to open up a new terminal shell, and I'm going to cd into the desktop and create a new folder for our project. So I'll do make dir MERN JWT auth, and then I'm going to change into that directory. And here I first want to initialize our project with git. So I'll do git init. Now let's create a git ignore. So we'll do touch.gitignore, and that should get created. And then let's open up this project in VS Code. I'm going to zoom in a little bit and then open up the terminal shell in here. Now let's add some content to our git ignore. And I'm just going to paste in all these things, and let's just save that. Now let's create a backend directory for our API code. So I'll create a new folder called Backend. And then in our terminal, let's change into that backend directory. And now let's initialize it with npm. So we'll do npm init-y. And that's going to create this package JSON. So we could see that created here. And now we need to install all of our packages. So I'm just going to paste them in, but you could see we're installing bcrypt, cookie parser cores, and a bunch of other packages that we're going to need for our API. So those were added as dependencies, and since we'll be using TypeScript, we also need to install the type files for these libraries. So I'm going to paste in some more packages, and these will be dev dependencies, so make sure to prefix it with the -d flag. But these will just allow us to use TypeScript in our app for the different packages that we're using. We're also installing TypeScript itself and ts-node-dev to run our TypeScript dev server. So let's go ahead and install these as well. Now let's add an nvm rc file so we can lock down the node version of our API. So we'll create a new file called .nvm rc. And then we need to paste the version in. So we're going to use node 18.18.2. So now anyone that uses this project needs to have node 18 installed. Now we need to create our tsconfig file so our TypeScript compiler knows which version we need to compile to and all of our configuration. So in our terminal, let's run a command called npx tsc-init, and that's going to create a tsconfig.json file. And if we open that up, you'll see we have a bunch of different TypeScript configuration options, and we only care about a few. So our target is going to be ES 2020, so we can use modern features. Then let's scroll down to the root dir. I'm going to decrease the size of this left pane to make this a little bit easier to see. So we need to find the root dir, and we'll change that to source. So all of our source files are going to be in the source directory. So this is telling TypeScript that all of the TypeScript code that we want to compile will live in the source directory. We also need to specify our outdir. So if we search outdir, this will be the folder that our compiled TypeScript code will be saved into. And it's convention to call this dist. So all of our resulting JavaScript code will live in the dist directory. And lastly, let's scroll down all the way to the bottom and add a new property called exclude. And we just want to exclude the node modules because we don't need TypeScript to compile those. All the other defaults are fine to leave, so let's just save that. Now we're ready to create our Express server. So in the backend directory, we'll create a new folder called source. And in here, we'll create a file called index.ts. And this is going to be the entry point to our application. So we'll do const app equals express, and then let's make sure to import express above. And now we need to listen for requests. So we'll do app.listen, and we're going to listen on port 4004. And then we're just going to create a function that will log out server is running on port 4004 in the development environment. So now let's save this. Now to run this, we can't do something like node index.ts because this is a TypeScript file. So instead, we're going to be using a package that we installed called tsnodedev, and it's going to take a look at our source directory and watch all of our changes. And anytime we make a change, it'll build our code and serve it as if it was a normal JavaScript file. So in our scripts here, let's create a script called dev, and that's going to be equal to tsnodedev, and then we're going to pass the -- files flag, and we'll just say source/index.ts. So now if we save this and run the dev script, our tsnode package is going to look at this entry point and compile all of our TypeScript code. So in the terminal, let's run npm run dev, and that started up our Express server, and we see that it's running on port 4004. So now let's open up Postman and just verify that it's running. And we get this error saying cannot get, but that's because we haven't defined any paths. So let's just add a health check route. So right below our app, we'll do app.get, and then the path will be the root directory. And then let's return a status of 200, and then add some JSON. And we'll just say that status is healthy. Now let's save this, and you'll see that our server restarted and our Postman route should get that response. And there we go. So our server is up and running. Now, instead of building out all of the endpoints in Postman to test our API, I've already exported a Postman collection. So if you open up the GitHub code, which will be linked in the description below, and you go into the backend folder, there's this postman.json. I'm just going to download this file here. And then let's go back into Postman, and there's this import button. So I'll click that, and then I just need to find the file. It's in my desktop, and that should import it into our workspace. And here we have our health check, all of our auth endpoints, user and session, and they're already configured to send the right payloads that we've built in our API. Before we start building out the endpoints, I want to go over the API architecture. So if you go back to the README at the root directory here, I've added some documentation. So let's scroll down to the API architecture, and we'll see that the API is built using different layers. We have routes, controllers, services, and models. So the routes will be responsible for handling incoming requests and passing them on to the appropriate controller. The controllers are responsible for validating the requests calling the appropriate service and then sending back the response. Services are where all of our business logic lives, and they interact with the database or external services, and services can also call other services. So think of them as just chunks of business logic that can be reused within our app. And lastly, we have models, which are just responsible for interacting with the database. They contain the schema and all of the methods for getting and updating our data. So there are some exceptions for controllers that are simple get or delete, where they don't require any business logic. We could just call a model directly and return the response. For our error handling, we're going to handle all of our errors with our custom error handler middleware, and that's just going to be handled in one spot in our app. So all of our controllers need to be wrapped with an error catch utility function so that it passes any thrown errors to that middleware. And you'll see this in the code. I also have a video that goes over express error handling, and you can go back to that video if the code doesn't make sense here. So with all that in mind, we can go back into our code and start building our endpoints. Let's go back to our server code, and right after the server starts up, let's connect to the database. I'm going to be running MongoDB locally, but you can also use MongoDB Atlas to run it in the cloud if you don't want to deal with all the setup. If you want to set it up locally, then in the README, I've left a link to the instructions. So if you go here, you could check this download link here, and that just takes you to the MongoDB docs, and you can scroll down to find your platform and the edition you want to download. I'm on Mac, so I'll go here. And I'm also using Homebrew, so I just followed the steps here. So I have this installed, so I'm going to go back to the terminal here, and I've created an alias just called Mongo. So if I run Mongo, it's essentially just going to run brew services start and then the version that you downloaded. And again, this is all in the docs on MongoDB, so you can just run this command to start your database. So now that it's running, I'm going to open up MongoDB Compass, and that's just a graphical user interface for interacting with our running MongoDB database. So I want to connect to MongoDB on this local host. So I'm just going to connect, and you'll see all of our databases here. Now we need to create a new database. I'll call it auth_db. And then we need to specify a collection name. So for now, we'll just say users, and we'll create this in our code in a second. So our database is created, and now we should be able to connect to it from our code. Let's go back into our API code, and I want to create a utility function for connecting to our database. So let's create a new folder under source called config, and in there, we'll create a new file called db.ts. Now in here, we're going to create a new function called connect to database. And it's going to be async. And inside, we're going to have a try catch block. And what we're going to try to do is await mongoose.connect, and we're going to pass in our Mongo URI from our environment. Let's make sure to import Mongoose at the top. And if there were any errors, we just want to log those out. So we'll say could not connect to the database, and then let's also log out the error. Then let's just call process.exit and pass in a status code. So this will shut down our server if it can't connect to the database. Let's make sure to export this connect to database function. And now let's take care of this TypeScript error. So TypeScript is saying argument of type string or undefined is not assignable to parameter of type string. This is happening because the mongoose connect method expects a string here. However, this process.env.mongoURI is of type string or undefined. And because it could be undefined, we can't pass it in to this connect function because this requires a string. So to get around this, we're going to create a constants file for all of our environment variables and validate that they're defined. So then when we import them, TypeScript will know that it'll be a string. So let's create a new directory under source. We'll call it constants. And inside constants, we'll create a file called env.ts. And here we're going to export all of our environment variables. So to do that, we need to create a .env file. So under Backend, we'll create a file called .env. And I've included a sample env in the finished code. So let's go back to our GitHub repo. and in the backend folder, go to the sample env, and I'm going to copy these contents and paste those in. So we have our node environment set to development, our app origin, this will be our front end URL, the Mongo URI, which is the path for a running database. So I've left an example here, and for the database name, we called it AuthDB. So that's the value you want to change in here. And if you're running this on MongoDB Atlas, there's a way to get that URI, and you'll just want to paste that in here. Then we have our JWT secret and refresh secret. You can change these if you want. And for our email sender, for now, we're just going to type a string, and our resend API key will just be a test string for now. Now that we've defined these, we can go back into our env constants file and export these constants out. So we could do export const mongo URI, and that's going to be equal to process.env.mongo URI. Now let's take this variable and import it in our db.ts file. So I'm going to import that at the top, and you'll see that it's still yelling at us because the typing is still string or undefined. To fix this, let's go back to our env file, and you'll see here it's still string or undefined. So we need to create a method for validating that this is actually a string. So at the top, I'm going to create a function called getEnv, and it's going to take in a key, which will be a string, and then an optional default value. So we'll add a question mark and say that it'll be of type string, and it's going to return a string. Now let's open our function parameter, and in here, we want to try to grab the value that was requested. So we'll do const value is equal to process.env, and we're going to pass in the key. And if it doesn't exist, we're going to use the default value. Now we'll check if value equals undefined. Then we're going to throw an error. So we'll do throw new error, and then we'll pass in missing environment variable, and then pass in the key. Lastly, if the value is defined, then we just want to return the value. So if we hover over the typing for this, we see that it takes a key string and it returns a string. Because if this variable was undefined, it's going to throw an error and never reach this return statement. So now we can refactor this code to call getEnv and just pass in the Mongo URI. And when we hover over the typing here, we'll see that it's of type string, and we no longer have to deal with it potentially being undefined. So now when we save this, we can go back to our DB file, and this is all happy. So now let's export the rest of our environment variables, and I'm just going to paste them in. Now we can use all of these within our code base. Let's go back into our index.ts file and connect to our database. So first, let's make the function async, and right below, we'll call await connect to database, and then import that at the top. So now when we save, we should connect to our database, and our environment variable is missing. So the reason this is happening is our server doesn't actually know about these environment variables, and that's because we haven't used this package called .env. So at the top of all your imports, you want to write import.env/config. So this is just going to allow our server to read the environment variables in our .env. So now if we save, we could see that it's running on port 4004, and there were no errors. I also want to add a log for telling us that we connected successfully. So we'll do successfully connected to the database, and now when we save, we can verify that we've connected. Now let's go back to our server and replace these hard-coded values with constants. So let's bring in the port environment variable. And then instead of development, we're just going to say node env. And the port in this file, I've added a default value of 4004. So that's what it's going to use since I don't have it defined in my env. So let's save this. And the next thing we need to do is add our middleware. So right below our app here, let's do app.use, and we'll pass express.json. And this just allows our Express server to parse JSON request bodies. And then let's also add this express.url encoded to parse form data. Then let's add our CORS middleware. So we'll do app.use and then we'll call cores, and we need to import it at the top. So we'll do import cores, and we need to invoke this function and pass in some options. For our origin, we're going to pass in the origin from our environment variables. So app origin, and that's going to ensure that only our front-end code can access this API. Then we're going to set credentials to true, and that's just going to send the access control allow credentials header back to our front end. Then we need to define our cookie parser middleware. So we'll do app.use and then pass in cookie parser. And then below all of our routes that we're going to define, we want to pass our error handler middleware. So this has to go all the way at the end. So we'll do app.use and then pass in error handler. So this middleware will catch all the errors that are thrown in any of the routes above, and all of our error handling logic will live in the middleware. Under source, let's create a new folder called middleware. And inside, we'll create a file called error handler. In here, we'll declare an arrow function called error handler. And we need to pass 4 arguments. And these 4 arguments are what's going to tell Express that this is error handling middleware and not just regular middleware. So we'll pass the error, which is the first parameter, the Express request, response, and the next function. And right now we're not getting any typing for this. So we can provide the typing here. We'll add a colon and say error request handler. And that's going to come from Express. So now when we hover over error, and the request will get all of the typing. So first, we're going to want to log out the path, and that'll be accessible on the request.path. And then we want to also log the error itself. So this will just give us some nice debug info for all the errors that were logged in our app. And then for now, we'll just return a 500 with internal server error. Then let's export this at the bottom, and now we should be able to use it in our index file. So we'll import this here. Now let's test that our errors are actually getting passed down to the handler. So in our health check, we'll just throw a new error called test error. Now we'll save this and go into Postman. Under the health check, we'll just send a request. And we'll see internal server error with a 500. And if we go back to our console, we'll see the path that was logged, and this is a test error. So it is going down all the way to our handler and being processed correctly. Now, what happens if we turn this into an async controller? So let's save this and clear the console, go back into Postman and retry the request. So you'll see that the server actually crashes and we don't get a response. And the reason for this is when we made this async and this error was thrown, this became a promise rejection. So when we made it async, this function returned a promise, and when the error is thrown, it was a rejection. And in Node, we need to make sure that we catch all rejected promises. So to do that, we can just wrap it in a try catch. We'll move this error in the try block, and then we'll catch the error, which was thrown here. And then we want to pass it along to our middleware. So let's get access to the next function. And in here, we just need to call next and pass in the error. So this will pass the error on to the next middleware, which when it goes down, it'll be our error handler. And then let's move this return statement up here. So now when we save this, we'll clear the console and make sure that this works again. And there we go. So our error makes it back into our error handler middleware, and we see the request path logged. So we just need to make sure that we wrap all of our async controllers with this try catch, and then call this next function and pass in the error that was caught. Now this code is kind of ugly, and I don't want to have to do this on every single controller that we make. So I'm going to create a utility function that's just going to take in an async controller and try to run it. And if any errors are thrown, it'll catch it and call the next function. So all of it will be abstracted away. Under the source directory, let's create a folder called utils. And inside utils, we'll create a file called catcherrors.ts. And this will export a constant called catcherrors. It's going to be a function that will take a controller as a parameter. And we need to define the typing for this controller. So if we look back at this controller, it's going to be an async function that takes these three express parameters, the request, response, and next function. So let's add a custom typing for this since there's no one built in. We'll do type async controller is going to be equal to a function. It's going to get the request, response, and the next function. And this all comes from Express. So we need to import these typings. And then it's going to return a promise of type any. So that'll just allow us to be dynamic. And now let's pass this typing for our controller parameter. Now this function is also going to return an async controller. And in here, let's get rid of these curly braces and return an async function. And this function is going to get access to the three parameters, request, response, and next. And it's going to run our try catch. So we'll say try catch, and it's going to try to run our controller that was passed in. And we're going to make sure to pass in all the parameters. And if any errors were thrown during this controller, we want to catch those and pass them on to our error handler middleware. So we'll call the next function and pass in the error that was caught. Now let's export this at the bottom. Now let's save and use this in our code here. So let's get rid of this try catch. And now all we have to do is wrap this async controller in that catch errors function. So I'm just going to copy this and move it into the catch errors function. And now when we save, we'll see that this matches the typing because catch errors takes an async controller, and this is an async controller. And now any errors that we throw inside here are automatically going to be caught and passed on to our error handler. So now let's test this through Postman, and we'll see that it works. We're getting a 500 internal server error, and we see the path being logged. So now every controller we create, we just need to wrap it with catch errors, and that'll all get passed down to this middleware. Now let's get rid of this error here, and we don't need this to be async anymore. I forgot to add a constants file for all of our HTTP status codes, so let's go ahead and add that in. Under constants, let's create a file called http.ts, and I'm going to paste in all of our HTTP status codes. So this allows us to use the human readable version of the status code and not just the number. So let's save this and add that constant here. So we'll do OK. And then in our error handler here, instead of 500, we want to pass the internal server error. So now it makes it a little more human readable, and we only have to define the errors once. I also forgot to swap the port in here. So let's just make sure we're using the same environment variable. And now we're finally ready to get started on our auth controllers. Let's go above our error handler and define our auth routes. So I'll do app.use, and I'm going to prefix all of our auth routes with /auth. And then we want to pass in auth routes. And now let's create a routes file for these auth routes. Under source, we'll create a folder called routes. And inside routes, we'll create auth.route.ts. In here, let's define a constant called auth routes, and that's going to be equal to a new router, and that comes from Express. And now let's just add a comment so we know that our prefix is /auth. And now let's start on the register route. So if we go back into Postman and click on register, we'll see that the path is /auth/register. It's a post request, and it expects a request body with email, password, and confirm password. So let's create the /register route and then forward it to a controller. Back in here, we'll do auth routes.post. The path will be /register. And then for the controller, we want to call the register handler. So handler is synonymous for controller. Now let's create this handler or controller. Under source, we'll create a folder called controllers. And in there, we're going to do auth.controller.ts. And then we're going to export a constant called register handler. And we're going to wrap it with the catch errors utility function. And then pass in our async controller. So it'll be an async function, take request response, and then open up the body. As I mentioned earlier, our controllers are responsible for three things: to validate the request, call a service, and return a response. So let's just start building out each of these steps. To validate the request, we need a request schema. We're going to be using Zod to do our schema validation. So let's go above and define our register schema. We'll do const register schema. And this is going to be an object. So we can call Zod.object. And let's just import this at the top. Then inside the object, we're going to define all our properties. So we want the email, that'll be a Zod string. Then we'll call the email method, and we'll also add a minimum of 1 character and a max of 255. Next, let's define our password. So we'll say password, that's going to be a Zod string as well. We'll set the minimum to 6 characters and a max of 255. Then we'll want our confirm password. And that's also going to be a Zod string, and it's just going to match the password schema here. And lastly, we want the user agent. So we'll say user agent, and that's just going to be a string, and we'll also make it optional. Now we need to verify that the confirm password actually matches the exact same value as the password field. To do that, on our schema here, we could tack on a refine method, and here we need to pass it a function. So the function is going to get our input data, and then we want to run a custom validation. So we're going to check if the data.password field is equal to the confirm password field. So if this is true, then our schema will be validated without any errors. If it's false, then Zod will throw an error, and we need to pass it some options for the error. So we'll say we want a message of passwords do not match, and the path or the property that this failed on is confirm password. So let's just pass that in. Now we're ready to use this schema. So in our handler here, let's say const request is going to be equal to the register schema, and then we're going to call the parse method. Then inside, we need to pass the data that we want to validate. So we're going to spread out the request body, and then we want to add our user agent, and that's going to come off of the request headers and then the user agent header. The nice thing about Zod is if this schema is valid, then we automatically get the typing for it. So if we hover over request, we'll see that a request is all of these fields, and it knows that email is of type string and password is a string, all based on this schema that we've defined up here. So we don't have to typecast or pass in any generics, which is really nice. If the request payload was not valid, then Zod is going to throw an error. And when an error gets thrown here in our handler, it's going to be caught by this catch errors function. So if we go in here, it's going to get caught right here and then passed on to our error handler. And if we open that up, it should log the error and then return a 500. So let's just save our files. Now let's import this controller before we start testing it in Postman. We'll go back to our route file and just import our register handler. And then we'll go back out to our index file and import the auth routes. We just need to make sure that we're exporting them here. Now we should be good to import. Now we should be able to test this in Postman. So let's mess up one of these fields. We'll just say emails, send the request, and we see internal server error. If we check our server logs here, we should see that error logged. We see the path was /auth/register, and it was a Zod error. And here is that error object. So there's a code, there's a path, and a bunch of other details on the error. There's also this errors array. Instead of returning a 500, I want to actually return a 400, which is a bad request, and some details about what went wrong, like what fields were invalid. To do that, let's go back to our error handler. So let's just search error handler. And in here, we need to add some extra logic to check if the error that is passed in here is a validation error. So let's add an if check. We'll check if the error is an instance of Zod.Zod error. And let's just import Zod here so we get the typing. Now, if this is true, then we want to call return handle Zod error. And we're going to pass in the response object and the error itself. Now let's create this function above. So we'll do const handle Zod error. That's going to take in a response, which is a express response. So we'll import that from express. Then the error is going to be of type Zod.Zod error. Now inside, we just want to return a new response. So we'll say res.status. And then the status code will be bad request, which is a 400. Then we'll add some JSON. So we'll say .json. Then we want to pass the message, and that's going to be equal to this error.message. And we get the typing off of that, so we know that the message will be there. Then I also want to return the errors array, but I don't want to return all of this info. I just want to take a few properties off of it because the others won't be that helpful. So right below the message, we'll just say errors. Now let's create our mapper function above. So we'll do const errors. It's going to be equal to the error.issues. And this is going to be an array of Zod issues. So we want to map over those. And for each issue or each error, we could call it, we're going to return a new object. Then we'll set the path, and that's going to be equal to the error path. And then we'll call it the join method. And this will basically take the entire path if we have any nested attributes and combine it into one string separated by periods. Then we'll also pass the message, and that'll just be the current error or current issue message. Now if we save, we should see a little nicer error response. So let's go back into Postman. We'll mess this up and hit send. And now we see our errors array. It's just path email and it's required. Now this message isn't that helpful, so maybe we should change it to just bad request, but I'll leave it for now. Now let's test that our confirm password is working. So I'll set the email back to a valid value, and for our confirm password, I'll just add a character. And now we see confirm password, the passwords do not match. So it looks like our schema is working properly and we're getting a 400 bad request, so that error handling looks good. Now let's go back to our controller and start adding our service. So now let's go down here and we need to create a service file. So under the source folder, we'll create a folder called services. And in here, we'll create a file called auth.service.ts. And in here, we want to export a concept called create account. And this is going to be an async function, and it's going to need to take some data. So we'll just call this data, and we need to pass a type for it. So let's go ahead and create the typing above. We'll do export type create account params. And this is going to be an object. We're going to have the email, password, and user agent. So we don't actually care about the confirm password because that has already been validated. So now we can pass these create account params as the typing for this data coming in. And now let's write out all of the business logic that needs to take place for an account to be created. So first we want to verify that an existing user with the email doesn't exist. So we'll say verify existing user doesn't exist. If they don't exist, then we want to create the user. After creating the user, we want to create a verification code so that they can verify their email. Then we want to send the email. After that, we'll create a session in our system. and then sign our access token and refresh token. Then lastly, we just want to return the new user and the access tokens. So this is all the business logic that needs to take place in our service. As I mentioned earlier, our services will call different models to interact with our database. Right now, we don't have any models, so let's go ahead and create those. First, we want a user model to check if any existing users are in our system. So under source, we'll create a folder called models, and then a file called user.model.ts. And in here, we're going to define the typing for our mongoose model. So we'll do export interface. We'll call it user document, and it's going to extend the mongoose.document. And this will just give us the typing for different methods and MongoDB properties that are found on the document. So now we want to define all of our properties. So our user is going to have an email, a password, created at, updated at, and then we also want to add a verified property, and that's going to be a Boolean. And then we want to add some handy methods on our user document. So we'll have compare password, and that's going to take a value, which will be a string, and it'll return a promise of type Boolean. So now let's actually create the mongoose schema. So we'll do const user schema is equal to mongoose.schema. And then through the generic, we're going to pass in the user document. And now we need to invoke this and pass in the mongoose typing. So in here, we're going to have an email. That's going to be of type string, and we want to set unique to true. Then we also want to make it required. So we'll do required and set that to true. Then we want a password, which will be of type string and also required. Then the verified column, that'll be of type Boolean, and it'll be defaulted to false. We also want to pass the required true. Then as a second parameter, we can pass some mongoose options. So I want to set the timestamps to true, so it'll automatically generate created at and updated at for us. And we don't have to define it as a property here. Now let's add some schema hooks. So on the user schema, we can define hooks that will run before certain events occur. So we can call the pre method, and pre-save, we want to run a function, and it's going to be async. And before we save a new user, we want to hash their password. So we have access to this variable, and that's going to refer to the user document. And we'll say this.password is equal to bcrypt.hash. And then we need to call the next function so that it runs any other hooks and continues on. Instead of hashing the password directly like this, I'm just going to create a utility function for it. So under utils, I'll create a file called bcrypt. And in here, I'm going to export a constant called hash value. And that's going to be an async function. It's going to take a value that is of type string, and then an optional second parameter of salt rounds. And that's going to be of type number. And then we want to call bcrypt.hash and then pass in our value and our salt rounds. And if there were no salt rounds passed in, we'll default it to 10. Now we need to import bcrypt. So this hash value function will return a promise of type string because the bcrypt hash function returns a promise of type string. We're also going to want a function for comparing the value. So we'll do const compare value is equal to an async function that takes in the value and the hash value. So this would be the plain text string that the user sends over, and this would be the hashed version in our database. And we're going to want to compare those two. So we'll return bcrypt.compare, and we'll pass in the value and the hashed value. And I'm just going to rename this to hashed value. And this compare method actually throws an error. So we just want to catch that error and return false. So that when we call compare value, it's just going to return a Boolean, and we don't have to worry about wrapping it in a try catch or having it throw the error. So now that we have these functions, we can go back to our user model and import them in. So this will now become hash value. And then we'll pass in this.password. And we just want to make sure we await this because this function is async. Lastly, we need to add a check. If the password hasn't been modified, then we don't want to run the hash function. So this is a built-in function in MongoDB. So this dot is modified, and then the property we want is password. So if it's not modified, we just want to return out and call the next function so that it doesn't continue on to hash the password. Now let's add our compare password utility method. So we'll do user schema, and this is just going to be a static method on the user model. So it's not going to be a pre or post hook. So to do that, we need to pass it to the methods property. We'll call it compare password. That's going to be equal to an async function that's going to take a value of type string. And it's just going to return the output of the compare value function we created earlier. Then we're going to pass in the user value and this dot password. And this will be the password field on the user model when it comes back from the database. So this will be the hashed value. So now our compare password matches this typing here, takes a value and returns a Boolean. And the last thing we need to do is create the actual model. So we'll do const user model is equal to mongoose.model. And we're going to pass the user document through the generic and then give the model a name. We'll just call it user and then pass in the schema. Now let's export this model so we can use it in our service. Now that we've defined the model, we can go back to our auth service and use it. So we'll do const existing user is equal to await user model. And then we want to call the exist method, which will return a Boolean that tells us if the record exists based on the criteria passed. So we want to pass email, and that's going to be equal to the data.email, which was passed in. So this will return the existing user with their ID or null. So now we can check if there's an existing user, then we're just going to throw an error saying user already exists. So now we can go and create the user because now we know that there's no existing user. So let's do const user is equal to await user model.create. And then we need to pass in the payload for our user. So we'll pass the email, which is data.email, and then the password. And now if this runs successful, then we're going to get the new user back. And this is the typing. It's a document with all of our user properties and methods on it. And if this function fails, it's just going to throw an error. So we don't have to do any sort of assertions on this user object. Now we need to create the verification code, and we don't have a model for that yet. So let's create that model. Under models, let's create a new file called verificationcode.model.ts. And in here, we're going to do the same thing as before. So we'll export an interface called verification code document. And that's going to extend off the Mongoose document. And here we want to add our properties. So we want a user ID, and that'll be equal to the mongoose.types.objectID. And this will be the TypeScript typing for this object ID. Next, let's add the type. This will be the verification code type. And instead of just setting this to a string, I want to create an enum so that we can only use specific values on this verification code document. Only the types of verification codes that our app uses. To do that, let's create a file under constants, and we'll say verification code types. And in here, we'll declare a const enum called verification code type. And it's going to have two values. First will be email verification, and that'll be the string here. Then we're also going to have a password reset. So we'll add that as well. And let's export this at the bottom. And I'm using a const enum here instead of a regular enum, so that when this code compiles to JavaScript, it's going to inject these values everywhere in our code instead of creating an object with these keys and values and then referencing this object in our code. So you can read up on const enums if that doesn't make sense. Now let's go back to our model and use this verification code type. Here we'll paste that in. So now our type here is locked down to only those values. Next, let's add our expires at time, and that's going to be of type date. Then we also want a created at, which will be a date as well. Now let's create our schema. So we'll do const verification code schema. That's going to be a new Mongoose schema. We'll pass in the verification code document. And now we need to define our Mongoose types. So first we'll have a user ID property. That'll be of type mongoose.schema.types, and then the object ID. So this typing refers to the Mongoose schema type, not the TypeScript type that we used up here. So make sure that this is coming off the schema.types property. Then we need to add a reference. So we'll say ref, and we want it to reference the user model. We'll set required to true, and then we also want to set an index. So we'll set index to true, so that anytime we query by the user ID, it'll be much faster because there's an index on it. Now let's add our type. So we'll say type, it'll be a string, and it'll be required. Then let's add our created at, which should be of type date. It'll also be required, and the default value will be date.now. Then lastly, we'll add our expires at. It'll be a date and also required. Then we'll close out this paren. Now let's create our model. So we'll do const verification code model will be a Mongoose model. We'll pass in the document, give our model a name of verification code, and pass in our schema. Then I want to pass a third parameter here, and we'll just pass a string called verification underscore codes. And this is going to override the default collection name, which would just be verification codes as one word, but that's not as readable. So I just want to add an underscore here. So that's how it'll be created in our MongoDB database. Now we're ready to export this model. So we'll just do that. And let's bring it into our service. So we'll go back to our auth service. And in here, we want to create a new verification code. So we'll do const verification code. It's going to be equal to await verification code model. Then we'll call the create method. First, we'll pass in our user ID, which will come from the user that was created above right here. Then we need to pass it a type, and that's going to be verification code type dot email verification, so that we're using this string value. Then we need to set the expires at, and I'll set this to 1 year from now. That'll be a function. So let's go ahead and create this function. Under utils, we'll create a file called date.ts. This will have a bunch of date utils. So we'll say 1 year from now, that's going to be a function, and it's going to return a new date. And in here, I want to pass the millisecond value of 1 year from now. So first I'll get the current date in milliseconds. This is UTC time. Then we'll add 365 days times 24 hours times 60 minutes times 60 seconds. And then we want to get the millisecond value, so we'll multiply it by 1,000. So this will give us the 1 year from now millisecond value. Now let's save this and import it back in our service here. Now let's keep going down our flow here. We're going to ignore this verification email for now, and we'll come back to it when we set up Resend. So the next step will be to create a session. A session is going to represent basically a unit of time that a user is logged in for. So when a user logs into our app, it'll create a session that will be valid for 30 days, and that user will be able to use the access token and refresh token to stay logged in to this session for 30 days. And that refresh token that is generated will be used to refresh the access token for this session. So if this session gets removed, then that refresh token will no longer be valid. Now let's create our session model. Under models, we'll create a new file called session.model.ts. And in here, we'll export another interface. We'll call it session document, and that's going to extend the Mongoose document. In here, we'll add a user ID, which will be the same type as before. And we also want to add a user agent, and this will be optional, so we'll add a question mark. And this will be helpful because when a user signs in from a particular device, like an iOS device or a Mac, they'll be able to see which device that is, and it'll help them know whether that session is actually theirs or someone else accessed their account. Then we'll add a created at, which will be of type date, and then we'll add the expires at, which will also be a date. So this will be the date that the session is no longer valid. Now let's create our schema. So we'll do const session schema. It's going to be a mongoose schema. We'll pass in the document. And in here, we'll define the user ID again, and this will be the mongoose typing. So the reference will be the user model. The type will be the mongoose.schema.types.objectID. And we also want to index this property as well, because every time we query for a session, we're going to be passing a user ID. Now let's add our user agent, and that's just going to be of type string. Our created at will be of type date, and we'll have the same defaults as before. Then let's add our expires at time. That'll be of type date, and we're going to add a default value for it. So we'll say default, and here we want to do 30 days from now, because every session is going to be valid for 30 days. That's just something that we've defined, and you could change that if you'd like, but I'm going to go with that for now. So let's create this date function. Back in our date.ts, we'll export a new function called 30 days from now, and this will just perform that calculation. So now when we go back to our model, let's import this. Now, anytime that a session document is inserted in our database, it'll automatically get an expires at date of 30 days from now. So that's pretty convenient because we don't have to keep passing this in when we create these sessions. Now let's create our model. So we'll do const session model. It'll be the mongoose model. We'll call it session and pass in our schema. And then let's export this at the bottom. And now we should be able to use it in our service. So when we create a session here, we'll do const session is equal to the session model. We'll import that. We'll call the create method again, pass in our user ID and also our user agent. And this comes in off of our request parameters right here on this data property. Let's create our refresh token. So we'll do const refresh token is equal to JWT.sign. And this sign method takes in a payload. So our refresh token is just going to have the session ID that we created right above here. And the second parameter, we need to pass a secret. So we'll use the JWT refresh secret. That's from our constants file. Then as a third parameter, we can pass it some options. So we want it to expire in 30 days, not 7. And we also want to set the audience to user. This basically just defines who the JWT is being signed to. So it could be the user role or an admin role or any other audiences you want to define. Now let's create our access token. So I'm just going to copy this code. We'll rename it to access token. And we're also going to want to add the user ID as well as the session ID, because our access token is going to be used to authenticate the user on each request, and we're going to need to know which user it is. For our secret, we just want to get the normal JWT secret. The audience will be user, and we want it to expire in 15 minutes because it's going to be a short-lived token. Now that we have both of those, we should be ready to return our response. So we want to return the user, and then the access token and refresh token. Now let's go back to our controller and use this service. So in here, we're going to want to await, create account, and then let's pass in our request. And from this function, it's going to return our user and tokens. So let's get our user, then our access token and refresh token. So now we see the typing for all of these. Then let's return our response. So we'll say return res.status, and we're going to pass in created, which is a 201. Then we'll set some JSON, and we're just going to pass back the new user that was created. Now, before we actually return this response, we want to set the cookies because we want to return the access token and the refresh token in the cookies. So right before we return, we'll do set auth cookies, and then we'll pass in the express response, the access token, and the refresh token. And this will just be a utility function that will set these tokens on the response object with the required properties that we define. And let's get rid of this res dot here. Now let's create this function. Under utils, we'll create a file called cookies.ts. And in here, we're going to export that function. So we'll do set auth cookies. And we're going to get the response, the access token, and the refresh token. And let's create a typing for those parameters. So we'll do type params is equal to res, which will be the express response. Let's import that. The access token will be a string, and the refresh token will also be a string. Now let's pass these params as the typing here. Now we want to return the response.cookie, and we'll give the cookie a name. So we'll say access token. We'll pass in this access token as the value, and then we need to pass it some options, and these are of type cookie options. And I'm going to create a separate function for getting our cookie options because we'll need that across our code base. Let's also add the refresh token cookie. Now let's create our utility functions for getting our cookie options. First, we'll start by defining some cookie defaults that are going to be used for both access and refresh token. So we'll say const defaults. It's going to be of type cookie options, and that's going to come from express. In here, we'll set same site to strict. I'll leave a link in the description for an article that talks about the different values for same site and how these cookies get sent from different origins. So right now I won't dive into it, but we'll set it to strict. Then we want HTTP only to true. And this will ensure that the cookies are not accessible through any client-side JavaScript. So they're only sent through the HTTP protocol. Then we'll set secure to true. However, when we're running this in development, our React app's going to run on HTTP. So let's make this dynamic. Above, we'll define the secure constant, and we'll just say if the node environment is not development, then secure will be true. So if we're in any environment that's not the development environment, it will be secure. But if we are in development, then secure will be false. And that's exactly what we want. Now let's create our function. So we'll say const get access token cookie options. And this is going to be a function. It'll return cookie options. Now let's return that object. And in here, we want to spread those defaults. And then let's add an expires field. So in here, we'll set that to 15 minutes from now, because this is the access token. So we want it to match whatever our JWT token expire date is. Now let's create this function. We'll go back to our date utils, say export const 15 minutes from now. That'll be a new date. We'll let Copilot do the math for us. Then let's bring this back into our file and import it in. Next, let's define our refresh token options. So we'll do get refresh token cookie options. We're going to spread the defaults. And instead of the expire time being 15 minutes from now, I want it to be 30 days from now. We already have this function. Then the third parameter I want to set is the path. The path refers to which paths this cookie will get sent on. So I don't want the refresh token cookie to be sent on every single request. I only want it to be sent when the path is /auth/refresh. And this is going to increase the security of our refresh tokens because it's only ever sent on this path, which makes it a lot less likely to get stolen or tampered with. So let's close out these options here and use these functions below. So after our access token, we'll call get access token cookie options. And then for our refresh token, we'll call get refresh token options. So this function looks good. Now let's go back and use it in our controller. So we'll import it in here. And then we need to tack on a period here because this set auth cookies returns the express response. And that's how we can add the status and the JSON. So let's give this a save and test it out in Postman. We'll go back to our register endpoint and make sure all of our fields are valid. And we'll send a request here. And there's our new user that gets created. If we check our MongoDB database, we'll refresh, and here's our user. We could also see our verification code. That's our email verification. And then we also have a session. So it looks like all of the right records were created and our service is working properly. Let's also verify that the cookies were returned. So we can open up the cookies tab here and we'll see the access token. That's this string all the way here. Let's copy that. And we see that the expire date is in UTC time at May 12th, 1 a.m. I'm about 7 hours behind UTC, so this would be 6:20, which is about 15 minutes from 6:06, which is the current time. So that looks right. And if we go to our refresh token, we should see that the expire time is June 11th, and currently it's May 11th, so that's about 1 month from now. Now let's actually verify the payload of the JWT. So I'll go to a website called jwt.io. And in here, I'm able to paste in a token and see the contents. So there's our user ID and our session ID. And if we check our database, these will match. So 6640 for our user ID. And we see that right here. Now let's go back into Postman and try to hit this endpoint again. And right now you'll see that we get a 500 internal server error and we don't get any more details. If we open up our logs here, then we'll see that we get this error, user already exists. And that's because in our service here, our auth service, we're doing a check and throwing an error. However, this is just an inline default error. And in our error handler, when it catches this error, it comes in here. We're just returning this 500 with no message or no custom status. So we need to add logic to our error handler to handle those custom errors that are thrown within our services or anywhere in our business logic. I think now would be a good time to implement our own app error. This will be a custom error class that's used when we want to throw errors in our business logic. So each app error will have an HTTP status code, a message, and an optional error code. So when we throw this app error, we're going to define all these properties. Then in our error handler middleware, we're going to check if the error that was thrown is an app error. And if it is, we'll attach the status code, the message, and the error code to the response. We can also do any further processing if we need to based on the error code, like send an email or notify an external service or whatever we want. So it gives us a ton of flexibility around how we handle certain errors and how we return the responses. So let's go and create our app error class. Under the utils directory, let's create a new file called app error. And from here, we're going to export a class. We'll call it app error, and then it's going to extend off of the base error class. So we'll say extends error. Now let's add our constructor. And as the first parameter, we're going to take in the status code. So we'll say public status code. And for now, we'll set that to a number. And this is just a shorthand way of taking in a variable and assigning it to the class so that we don't have to do something like this.statusCode is equal to status code. So we can get rid of that because it'll automatically set this property by using this shorthand syntax. Our second parameter will be the message. So we'll say public message, and that's going to be a string. And then lastly, we want an error code. So this will be a specific app error code, and we're going to make it optional, and that's going to be a string. Now in here, let's call the super method, and that's just going to call the constructor of the base error class and assign the message to our app error. Then let's export this app error. And before we start using this in our app, I want to change this typing so that the status code has to be one of our HTTP status codes here that we've defined, because it wouldn't make any sense to pass a status code that isn't an actual HTTP status code. Let's go to the bottom and export a type called HTTP status code. And this is going to be equal to the type of all of these constants here. So I'm just going to tab that out and make sure that it grabbed all those values. And that looks good. So now when we hover over the status code, we'll see that it can only be one of these integers. Now we could take this typing and bring it into our app error class. Let's import that in. And now if we try to instantiate an error class, that will be enforced. So we'll test this out, call new app error, and let's pass in 200 and then a string message. So that seems to work. And if I pass a number that's not a status code, we'll get that type error. So that's working as expected. And now I want to do a similar thing with this error code property. So I want developers to only be able to pass specific error codes that we've defined within our API. I don't want this to be just a random string. Right now, we don't have any error codes. So let's create a file under constants and call it app error code. In here, we're going to export a const enum. So we'll call it app error code. And we're just going to have one value for now. It'll be invalid access token. That'll be equal to the string invalid access token. Then we'll close this out and export the enum. Right now, we only have this one error code, but as our API grows, we're eventually going to have more specific errors that we want to handle, and this will give us the flexibility to just add a new property here. So now let's bring this back into our app error class, and instead of this being a string, let's pass in the app error code, and we'll test it out down here. So if I just pass a random string test, then we'll see that it's not assignable to type app error code. And now if I give it a valid app error code, say invalid access token, then it's happy. Now I want to create a utility function for throwing these app errors. That utility function will try to assert a value, and if the assertion is false, then it'll throw this app error. And that's just so we don't have to do something like, if there's no user, then throw this new app error and then pass in the things. I don't want to have to deal with adding more scopes and using this syntax. So it's going to be a lot cleaner with our assert function, and you'll see that in a second. Let's get rid of this, and under utils, we'll create a new file called app_assert. And in here, I'm going to add a JSDoc comment. We'll just say asserts a condition and throws in app error if the condition is falsy. Now right below this, we could say const app_assert is going to be equal to a function, and it's going to take a condition. That'll be of type any, because it could be a string or a number or whatever we're trying to assert. The second parameter will be an HTTP status code. Then we want to grab the message, which will be the response error message. And lastly, we want to grab the app error code. And this will be optional. Once we have all these values, we want to call the assert function, and we're going to get that from Node. So we can go to the top and say import assert from Node assert. And now let's call that assert function. We'll pass in our condition. And then as a second parameter, we can give it a error object. So in our case, instead of the standard error, we want to create a new app error. So we're going to call new app error and then pass in the status code, message, and app error code. Then let's import our app error. And now we need to provide a typing for all these parameters because TypeScript is complaining. So let's get rid of this any, and we're just going to create a separate type above. We'll say type app_assert. It's going to be a function, and the condition will be of type any. Our HTTP status code is going to be that same status code type that we used before. So we can import that in. Then the message will be just a string. And lastly, our app error code will be of type app error code. So now all of these parameters match the input type of this app error here. Now we just need to define the response type. And we're going to say that this function tries to assert the condition. So we could say asserts condition, and this is just a keyword in TypeScript, which will tell the compiler that if we call this function and pass it a condition that could be null or undefined, in the code below this function, it'll know that this condition, whatever we tried to validate, does exist, and you'll see that in a second. Now let's pass this typing in for our function here. So we'll say AppAssert is of type AppAssert, and that should get rid of all of our TypeScript errors. Now let's export this function at the bottom. Now we can start using it within our app. Let's go back to our auth service here, and where we were throwing that error right here, let's replace this with our AppAssert. So I'll comment this out for now, and let's call AppAssert. We'll import that, and we want to assert that there's no existing user. So we'll add that check, and if this fails, meaning there was an existing user, we want to return a conflict error code, which is a 409. And for our message, we'll just say email already in use. And now we're getting this TypeScript error saying that an argument for app error code was not provided. And I think I forgot to make that optional. So let me just add a question mark here. And that should solve that error. Now let's get rid of this comment. And when an existing user does exist, this function will throw an app error with a 409 status code and this message. When this gets thrown, it's going to get caught by our error handler. So now in here, we need to check if this error that was passed in here is an app error. So let's check if the error is an instance of app error. Then we want to return handle app error. Then again, we'll pass in the response and the error itself. Now let's define this error handler. So we'll say handle app error, and it's going to take in the response, which will be the express response. Then the error will be of type app error. And now in the body of the function, we want to return response.status, and then we'll pass in the error status code. And the typing tells us that we know this will be an HTTP status code. Then we'll return some JSON. In here, we'll add the message, which will just be the app error message. And we'll also add the error code, which will be the custom app error code that we defined, or if it's not defined, then it'll just be removed. Now, if we save this, we should be able to test our app error function, and we should get a message saying that an email is already in use when we try to create the same user. Let's go back in a Postman here, and I'll hit send again. And you see we get the message email already in use, and it's a 409 conflict. So now the client will get a nice error message, and they'll know why the request failed. Now let's try to create a new user. So I'll call this user test2. And when we send this, we'll see our new user object. And you can also see that the password is being returned. Now, this is not a great practice, and you really should never send passwords back to the client. The reason this is happening is back in our auth service, when we create our new user here, this returns all of the properties of that new user. So when we go down here and return the user in the response, that includes the password field. To do that, we could add a helpful utility method on the user model. So we could call something like user.omitPassword. So let's create this now. We'll go back to our user model. And in here, we're going to add a new method. So we'll say omitPassword. And this is going to be a function. And it's going to return our user document. But we only want to pick off certain properties. So we'll add a pick. We'll say pick. And then off of the user document, we'll add a comma. And then specify the properties that we want to pick off of the document. So we're going to say _ID, then email, and verified. We'll also get the created at, the updated at, and lastly, the version. Now let's save this, and we need to add this omit password onto our model. So we'll scroll down here, and right below the compare password, we'll add another method. So we'll do user schema.methods. We'll call it omit password, and it's going to be a function. Inside, we want to grab the user data in an object. So we could do const object is equal to this.toObject. And this is a built-in method from Mongoose that will convert our user document into a plain JavaScript object. And we could just call that user. This user will have all of the fields of the document, but it's not going to have any of these methods like compare password. So when we call to object, it strips off all the helper methods and extra stuff that Mongoose adds, and it just converts it to just a plain JavaScript object. So then we can call delete and pass in our user. We want to delete the password field, and then we'll just return the user object. So now if we save this, then our TypeScript should be happy here, and we'll see that this user now is going to be the user document with only these properties. And let's actually test it out in Postman. So I'll go back and create test3. We'll hit send, and we see that the password isn't returned. So that's exactly what we want. Now we're ready to start on the login endpoint. So if we look at that here, it's a post request to /auth/login, and it just takes an email and a password. Let's go back to our controller and add that path. So let's go to the route file, and we're going to duplicate this. We'll call it /login. And now instead of this register handler, we'll just call this login handler. Now we need to create this controller. So we'll go back to our auth file, and we'll export another constant called login handler. We'll wrap it in the catch errors function, and it'll be an async controller. Then in the body, we need to validate the request. So we'll say const request is going to be equal to the login schema. We're going to call the parse method and pass in the request body. Now let's create this login schema. I'll go up to the top of the file, and I'm going to move the schemas out into their own separate file so it's not cluttered in this controllers file. Let's copy this, and under controllers, we'll just create a file called auth.schemas. And in here, I'm going to paste in our register schema and make sure to export it. Then we'll bring in Zod. And now let's define our login schema. So I'll do export const login schema, and it's going to be a Zod object. Now inside, we're going to have nearly identical fields as the register schema. So instead of duplicating them, I'm going to bring them out of this object and store them in a constant here. I'll paste that and just say const email is equal to this schema. Then I'll store the password in a constant. We need to get rid of these commas, and then I'm just going to say schema at the end of this so we know that it is the schema. Now in the login schema, we could say email is going to be the email schema, and then the password will be the password schema. Then we're going to add our user agent. So I'm actually going to cut that from there and paste it in here. And there's our login schema. But now we need to fix our register schema. So right now it just has our confirm password and not these three properties. So since we need these three properties that are on the login schema, we can call a helpful Zod method to extend off of this schema and then add this property. To do that, we just need to call login schema.extend, and then we'll get rid of this object method here. And now when we extend this schema, we can add additional properties that'll be applied to the register schema. So now when we save this register schema, we'll have everything in the login schema plus this field and this refine method. So it's going to work exactly as it did before. Now let's import our login schema back in our controller. And we'll also import the register schema. Now that we've validated the request, we want to call our service. So for now, we'll just add a placeholder here, and we'll call the service login user, and we'll pass in that request. Now let's go and create this service. Before we do that, I actually forgot to spread the request body and add the user agent. So I'm going to copy this line up here and add that in, because our login schema also requires a user agent. Now let's go and create login user. We'll open up the auth service file, and down below, we'll create login user. It's going to be an async function, and we're going to destructure some data. We want to grab the email, the password, and the user agent. and that's going to come from our params. So let's just copy the ones from above. We'll grab this type and paste it below. Then we'll rename this to login params. Now let's pass this typing in our params like that. Then we'll open up the body of our service, and then let's define all of our business logic that needs to take place. So first we need to get the user by email and obviously verify that they exist. If the user exists for the email, then we need to validate the password from the request. If the password is valid, then it means that the user is who they say they are, and we're good to create a session. So we'll create the session. Then we want to assign our access and refresh tokens and return those. So now let's just build this out step by step. We'll get the user by doing const user is equal to await the user model dot find one. And then we're going to pass in our email from the request. So this will either be our user document or null. Now let's add our app assertion. So we'll call app assert. Then we'll pass in our user. And if there's no user that's found, we'll just say unauthorized. Then for our message, we'll say invalid email or password. We want to keep this vague enough so that they don't know which one it is, either the email or the password. Now we need to validate the password. So we'll say const is valid, and it's going to be equal to the user. And we're going to call the compare password method and pass in the password from our request. This will return a promise that will resolve to a Boolean. So let's await that promise. And now let's add our app assert. We want to verify that the password is valid, and if it wasn't, then we'll return the same unauthorized error code and the same message. If we've gotten past these two checks, then it means the user is who they say they are, and we're ready to create a session. So first we'll get the user ID. So we'll store this in a constant up here. That'll be equal to the user above. And now let's create our session. So we'll say const session is equal to, that's going to be equal to await session model dot create. And then we're going to pass in our user ID and the user agent. Now I'm going to create a payload for our refresh token. We'll call this session info, and that's going to be equal to session ID. That'll be equal to the session ID. Now let's sign our tokens. So I'm going to just go up and copy and paste all of this code here and bring it back down. Down here, instead of passing this object, I'll pass the session info. This can stay the same. And then for our access token, we can just spread the session info like that, and we should be good to go. Then lastly, let's return our user and tokens, and make sure to call this user.omitPassword so that the password isn't returned. Now let's give this a save and go back to our controller here and import login user. From here, we're going to get the access token and the refresh token. We won't need the user, but they're there if we ever needed to have the user. And now let's return our response. We want to call this setAuthCookies method again. So I'm going to copy that over here. Then we'll add a status. That'll be a 200, so we could put OK. Then we'll send some JSON back with a message. Maybe we'll say login successful. So now when the user logs in, they should get a new access token and refresh token, and a new session will be created in our system. Now let's import this login handler in our route file. So we go in here. Now we should be ready to test this through Postman. Let's go back here and we'll try to log in the first test user. And we see login successful. Let's verify that our cookies were sent and those look correct. Now let's check our database to make sure a session was created, and we see a bunch of them. Before we move on to the refresh endpoint, I want to refactor our code. Back in our service here, when we're signing our tokens, you see that this code is very repetitive. We basically copy and pasted it from the code above, and If we were to ever change some of the options, like the audience or the expire time for the refresh token, we'd have to change it here and know to go up here and change it. And then anywhere else that we're signing refresh tokens or access tokens, we have to change those options as well. So this isn't ideal, and it'd be better to just create one signing function, and we could pass it a payload and some optional configuration, and that'll take care of signing the tokens with the right options and make it very easy to update going forward so that we only have to update it in one spot, and that'll get reflected across our code base. It's also going to slim down our code here, which is just going to make it nicer to read and easier to follow. So let's create those utility functions. Under utils, we'll create a new file called JWT. And in here, I want to export a function called signed token. This will be a function that takes a payload. And let's define our payloads that we'll accept. So we have a refresh token payload. So we could say export type refresh token payload, and that's just going to have the session ID. And instead of this being a string, I'll reference the session document, and we'll grab the ID property just to give us some context for what this ID is referring to. Now for our access token, we're going to do the same thing, access token payload, and we're going to have the user ID and the session ID. Now let's import this user document. So now we have our two payloads. So in our payload type, we'll pass access token or refresh token payload. Now anytime we call this function, our parameter has to match one of these objects. The second parameter is going to be the options, and these will be optional, but basically they're going to be the sign options from the JSON Web Token package, and we're going to tack on a secret. So if you look through these options, you'll see that there's an algorithm, expires in, audience, and all of these signing options from the JWT library. However, secret isn't on those sign options. We pass it in separately, but I'm just going to combine them all into one. Let's extract this type into its own type above. So let's do type sign options and secret. And that's going to be equal to the JWT sign options plus this secret property. Now we could pass this type in for our options. Now in the body of our function, first we want to grab our secret. So we'll destructure the secret, and that's going to come from our options. And if there were no options passed in, we're going to default them to our access token options. Right now we don't have those, so we'll default it to an empty object. Then after we get our secret, we want to get the rest of the options. So we'll use the spread operator and grab the rest of the sign options. So these will be all the JWT sign options that we just saw. And now we want to return JWT.sign. And we have to import this at the top because we're not getting the auto import. The sign method takes 3 parameters. So first is the payload. We'll pass in the payload from our parameters here. Then the next option is the secret, and lastly, the sign options. And this sign method will return a string, and that's going to be our signed JWT. So now TypeScript is complaining, saying that this secret is string or undefined, but we can't assign it to a parameter of type secret because we need this to be a string. It can't be undefined. And that's happening because if this is an empty object, our secret will be undefined. So instead, this should be our access token sign options. Let's go above and create those options. First, I'm going to create the defaults that'll be used for our access and refresh token. So I'll call this a default. It's going to be of type sign options. And our defaults for both tokens is going to be the audience. And that'll be user. And now we can create our access token options. So I'll say const access token sign options. That's going to be of type sign options again. In here, we're going to set the expires in to 15 minutes. And then our secret will be the JWT secret. We just need to import that in. And this is actually not going to be sign options. This will be sign options and secret. And now we can use these options as the default value here. And that makes TypeScript happy because now we know that the secret will be a string because it'll come in off of these options or the default access token options. Now let's create our refresh token options, which are going to be very similar, except the expires in will be 30 days and the secret will be the JWT refresh token secret. So that looks good, and we should be able to export these out because we're going to need to use them in our code base. And the last thing we need to do is use these defaults here. So I'll copy those, and instead of passing sign options here, I'm going to spread the sign options and also spread the defaults. So every time that we sign a token, it's going to set the audience to user. And if we want to override that, we'll have to pass the audience in these options here, because those will override the defaults. So I hope this made sense, but you'll see that it's going to clean up a lot of our code now. If we go back to our auth service here, we could change this access token to just be sign token. We'll import that. And we're going to take this object, pass it in as the payload. And we don't need to pass any of these other parameters because it's going to default to use the access token options, which is the normal secret and these other options. So I can just get rid of this call. Now I could do the same thing for the refresh token. So I'll call sign token. I'll pass in the session info. And then the second parameter will be the refresh token sign options that we just created. And I'll get rid of this. And you'll see that this slims down the code a lot. And if we ever need to update these options, I could just go into this file and tweak one of these objects, and it'll be reflected across our code base. Now let's go refactor the register service to use this new function. So we'll replace jwt.sign with just sign token and then remove these options. And then for our refresh token, we'll do the same thing. And we'll pass in our refresh token sign options. Let's also refactor this user.id because we keep referencing that, so it's better to just store it in a constant above. Right after we create our user, we'll do const user ID is equal to that, and then we can get rid of all of these references. And we'll just keep it as user ID. All right, so that looks good. Let's give this a save and make sure that we didn't break anything. So I'll clear my cookies and hit this login endpoint again. We see login successful, and we have our cookies here. And these look correct. Now we're ready to start on the next endpoint. So I'm going to build out the logout endpoint, which is a GET request to /auth/logout. So let's go and define that route here. In our auth.routes file, we'll copy this. We'll set the path to logout. And then we want to make sure this is a GET request. For our handler, we'll just say logout handler. Now let's create this controller. Right below the login handler, we'll say logout handler. And this is going to be a very basic controller. So first we want to grab the access token from the cookies. We'll say const access token. That's going to come from the request.cookies.access token. And now we want to verify the access token. So we'll try to get the payload off the token. And we need to try to verify this token because if it's valid, we want to delete the session that's assigned to that access token. Let's create a utility function for verifying tokens similar to how we did the sign token function. We'll go back into the JWT utils file. And down at the bottom, we'll export a new function called verify token. And it's going to be a function that will take a token to validate. That's going to be a string. And the options will be of type verify options. That's going to come from the JWT library. And we're also going to add the secret to these options. In the body of the function, we want to grab the secret again. So we'll say const secret, and we'll destructure the rest of the options as the verify options. Then we'll want to add a default to an empty object because these should be optional. So make sure to add this question mark. And now we want to add a try catch block so that any errors that are thrown when we're verifying a token will get caught, and I could just return an object with an error property instead of having to catch the error in my service or my controller. So in our try block, let's try to verify our token. We could do const payload is equal to JWT.verify, and the first parameter is the token we want to validate, then the secret. TypeScript is complaining here because it's saying that this secret could be undefined. In the case that no options were passed in and it defaults to an empty object, we want to make sure the secret has a default value of JWT secret, which is the access token secret. So that should get rid of that TypeScript error. And now the third parameter we need to pass are the options. So I'm going to spread our default, which is just the user audience right here. And then after that, I'll pass the verify options to override any defaults that were passed in. So if this payload is valid, then we just want to go below and return an object with a payload property. And that's going to be equal to the payload that was decoded here. Now in our error block, we want to return an object with our error message. So we'll set error, and that's going to be equal to the error.message. And now TypeScript is complaining because we need to set the typing on this error. We'll set that to type any. Now let's save this and use this verify token function in our controller here. So let's call verify token, and then we'll pass in our access token from the cookies that we got here. Now if we hover over payload, we'll see that it's either a string or a JWT payload or undefined. If it's undefined, it means that an error was passed, and we could destructure that error here. We'll see this is any, so that's not super helpful, but we don't care about any errors here. So now let's check if there's a payload. Then we want to grab the session ID and remove it from our database. So let's call await session model, import that, and then we'll call find by ID and delete, and then we'll pass in our payload session ID. Now TypeScript is complaining, so it's saying session ID does not exist on type string or JWT or JWT payload. The reason that's happening is because when we hover over this payload, TypeScript doesn't know that these payloads are really our access token payload or our refresh token payload. It just thinks it's a string or one of the default JWT payloads. So we need to tell TypeScript that this payload coming out is actually our access token payload. To do that, we need to update our verify token function. Let's go back in there, and we're going to use generics here. So let's open up these brackets here, and we could say type payload is going to extend the object, and that's basically saying this type that you provide is going to be an object. And if you didn't pass anything in, we're going to default to the access token payload here. And now that we have this type payload, when we call the verify function, right now this payload is string or these default JWT payloads, but we need to cast it. So we'll say as payload, and that's going to tell TypeScript that this payload is going to be this type payload that we got from our generic up here. So now if we save this and go back to our controller, when we hover over payload, we know that it's access token payload or undefined. And when we do this if check, it's verifying that the access token payload exists, and therefore we have this session ID. Now if we didn't add a default, so if we just remove this from here, then we'd have to pass it in as a generic here. And this would work as well. But since most times that we verify it's going to be the access token, I'm just going to leave it as the default. So let's add that back in. Now we should be good to go. So if the payload wasn't valid or if this token wasn't a legitimate token, then we don't really care necessarily. We just want to prevent running this database query. So if it's not valid, we'll just ignore it for now. And the last step is to clear our cookies. So when a user logs out, we want to clear all of their cookies so that they're not resent on subsequent requests. So we'll do return res.status. We'll just say OK, and then we'll send a message saying logout successful. Now before we return here, let's clear the cookies. And I'm going to create another utility function for clearing our cookies. We'll call it clear auth cookies, and it's going to take the express response object. So now let's go and create this function. In our cookies file here, right below our set auth cookies, we'll export clear auth cookies. I'm going to take in the express response, and it'll call res.clearCookie. Then we give the cookie name, which is access token, and then let's clear our refresh token. So we'll pass clear cookie and then the refresh token. But this time we also need to specify a path, and the path is /auth/refresh. Now this string is very important because when we're writing the cookie, it gets set with this path. So when we delete the cookie, we need to make sure that the path matches. And this would be a good case to use a constant so that if we update it here, we don't forget to update it down here as well. Let's just store this in a constant above. We'll say const refresh path. That's going to be equal to /auth/refresh. Let's make sure to export that. And now we'll replace these strings with that constant. Now, anytime we update refresh path, we just have to do it up here, and we won't have to worry about these cookies getting messed up. Now let's go back to our controller, and we'll import this function in. And now our cookies should be cleared when we log out. Let's go back to our route file and import our logout handler. And then let's open Postman and give this a test. So first I'm going to actually open MongoDB Compass. We'll go to our sessions and we're just going to clear all sessions for now. We'll start fresh. And now we'll log in with the user, test@test.com. So that's going to create a session. And we should see that session here. And now if I take the same test user and go to the logout route, our cookie here is going to be sent, this access token, and that should have the session ID, and that should delete our session. So we see logout successful, and if we refresh this, our session is removed, and our cookies should also be removed, and we don't see them here. Great, so that worked as we expected, and now we're ready to start on the refresh endpoint. Let's open up this refresh endpoint, and we'll see that it's a GET request to /auth/refresh. And this endpoint will be responsible for refreshing the access token for a given refresh token. Let's go back to our routes file here. And right below the login, we'll add another GET request to /refresh. And this will be the refresh handler. Now let's create this handler in our controllers file. Right below logout, we'll export refresh handler. And let's just add our boilerplate code. So here we want to first grab the refresh token. So we'll say const refresh token, and we're going to get that off of the request cookies. And let's typecast this as a string or undefined. So now we know that this will be string or undefined because if we didn't have that, this is just type any, and it's not that helpful. So we should also actually do this above right here. And now this is complaining, saying that we can't pass undefined to our verified token. So we'll just do or an empty string. That should satisfy TypeScript. Now let's assert that a refresh token is found in the cookies. So we'll say app assert. We'll pass in the refresh token, and if it doesn't exist, we'll throw an unauthorized error. And for the message, we'll say missing refresh token. Let's make sure to import this error code. And now we're ready to call our service because this request has been validated. Let's go and create that service. So we'll open up our auth.service file, and down at the bottom, we'll export a function called refresh user access token. And that's going to be an async function, and it's going to take in a refresh token, which is a string. The first thing we want to do is validate the refresh token. So Let's call verify token. We'll pass in our refresh token and then our options object. In here, we want to pass our secret, and that's going to be equal to our refresh token sign options. These are the options we use to sign the refresh token. Then we want the secret property. Now this function will return either a payload or an error. So we only care about the payload here. And right now it thinks that this will be the access token payload because that's the default. But we can pass in a generic here and tell TypeScript that it will be the refresh token payload. So now it should know that that'll be the refresh token payload. And let's assert that it exists. So we'll call app_assert, pass in the payload. We'll set the status code to unauthorized, and then the message will be invalid refresh token. So this would be if the token expired or was generated with an invalid secret or any number of errors. So now that the payload has been validated, we're free to get the session. So let's do const session. It's going to be equal to the session model.findById, and we're going to pass in the session ID from our refresh token payload. So now this will be either the session document or null. Now let's assert that the session was found. Then we'll pass the unauthorized status code. And for our message, we'll just say session expired. So this would be the case where a user signs in and a session's created and a refresh token is signed. And then the session later gets removed from our database before the 30-day expiration. And so the token was sent in the cookies, but our session wasn't actually in our database. Now we also want to check that if the session was found, that it's not expired. So let's add another check here. Then we'll check the session.expiresAt.getTime. That's going to return the millisecond value of this expires at date. We want to make sure that the expires time is greater than now. And let's just store that now in a constant. It'll be equal to date.now. So this will be the current UTC millisecond value, and we're checking that the session expiration is greater than the current date. So I hope that makes sense. Now we need to check if the session is expiring soon, because if it expires, say, within a day, then we want to refresh it. This will just improve the user's experience on the front end, because if you think about it, there is a case where a user can sign in, they'll get their access token and refresh token, and then they don't use the app for 29 days. And then on that last day, they're using the app and the refresh token is regenerating new access tokens. And so they're thinking that they're logged in and they're just using the app, but then it hits midnight and their refresh token expires. Meanwhile, they're still using the app. So that's just going to automatically log them out on a random request. So in order to prevent that, when they're regenerating access tokens by just using the app, we're going to check if the session's about to expire, and if it is, we'll just increase it to another 30 days. So it's going to give them that seamless experience, and they won't ever get logged out automatically on a random request. So let's add a comment here, and we'll say, refresh the session if it expires in the next 24 hours. Now let's check if we need to refresh the session. So we'll say const session needs refresh. And that's going to be equal to the session.expiresAt.getTime. We'll subtract now so that the expiration date minus the current date, that'll get the remaining milliseconds that the session is valid for. We want to make sure that that amount is less than 1 day in milliseconds. So basically we take the expiration date, subtract the current date, we'll get the remaining amount of milliseconds that the session is valid for. And if it's less than or equal to 1 day, then we want to refresh our session. Let's declare this constant in our date file here. Let's go to the bottom and export the 1 day in milliseconds. Let Copilot do the math for us and just double check that. So that looks right. And now we should be able to import this in. And TypeScript is complaining here. saying expires at does not exist on our session document. Did you mean, okay, so I think we made a typo here. On our session, let's open up our session model. We misspelled expires at, so let's fix that. And that should get rid of that warning here. Let's also update that property. Now let's update our session. So if the session needs refresh, then we want to set a new expires at time. So we'll set the expires at property to 30 days from now. We'll invoke that. And then we want to save off the session. So we'll await session.save. And that's going to set the new expires at time. Now you can run this on every time the access token is refreshed instead of just on the last day before it expires. But for now, I'm just going to leave it as is. Now we need to sign our tokens. So first let's sign our access token. That's going to be equal to sign token, and then we'll pass in the user ID and session ID. And now let's sign our refresh token. So if our session was refreshed and we increase the expires at time, we need to give the user a new refresh token because their old refresh token has the same expiration date as the original session expiration. So in order for their token to still be valid, we need to set a new refresh token. So let's go ahead and sign the refresh token. We'll say const new refresh token. And we want to check if the session needs a refresh because we only want to generate a new one if the session needs a refresh. So we'll call sign token, pass in a session ID. That'll be equal to the session underscore ID. Then we'll close out this payload. Then we'll add our refresh token sign options. Then let's close out this call and add our ternary. So if the session does not need a refresh, then we'll just set it to undefined. And we messed up one of these brackets here. I think it's this one. There we go. So now our new refresh token will either be a string or undefined. Now let's return these two tokens. So we'll return an object with the access token and the refresh token. Now this refresh token will either be a string or undefined, and if it is undefined, then back in our controller, we're not going to set this cookie. But if the refresh token does exist, then we do want to set the new cookie. Let's give this a save and go back to our controller here. Now let's call that service. So we need to await the refresh user access token, and then we'll pass in the refresh token from our cookies. This is going to return our new access token and then an optional refresh token. And we're getting a naming collision here, so I'm just going to rename this to new refresh token and also rename it down here. We'll just keep it as new refresh token so that it's more explicit that this is a new generated refresh token. And now let's return our response. So we'll call res.status and we'll pass in 200 for the status. Then we want to add our cookie and we'll set the access token. So we're going to want to set the access token every single time because this token will always be generated anytime that we're calling this endpoint. If we've made it here and the service ran successfully, we're always going to have an access token. So we're free to set that here. Then the third parameter, we want to call getAccessToken cookie options. And I don't think we're actually exporting this out of our cookies file. So let's go to the top and just export this out. Let's also export our refresh token function here. Now let's go back and import this in. So now we're setting our access token. And lastly, let's return some JSON here. And we'll give it a message saying access token refreshed. Now we need to add a final check here. So if there was a refresh token, we also want to set the refresh token cookie. Now I'm not going to do it in line like this because there's not really a great way to do that. So I'm just going to add an if scope up here. We'll check if there's a refresh token, Then we want to set the response cookie. We want it to be the refresh token. We'll set it to our new refresh token and then pass in our refresh token cookie options. So now this cookie will only get set if a new refresh token was generated. And let's actually make sure this is new refresh token. Let's go and import this handler back in our routes file here. Give this a save. Now let's test it out in Postman. So right now, if we look at our cookies, we'll see we don't have any. So we need to log in. And we see login successful. And we see our cookies here. Now I'm going to delete our access token and try to hit the refresh endpoint. So now if I send this, we'll see access token refreshed, and we get a new access token cookie. So that's working well. Now let's test removing the refresh token, and we'll hit send, and we'll see missing refresh token. It was a 401 unauthorized, so that looks like it's working. And I think we should also clear the cookies if there was an error. So if the user tried to refresh their access token and that resulted in an error, meaning their session wasn't valid or their refresh token was invalid, then we should clear any existing access tokens or existing refresh tokens. Because if they keep hitting this endpoint with an invalid refresh token, right now it's not clearing that from their cookies. So let's go back and add some more error handling logic. So we want to add a check. If the requested path is /auth/refresh, then we need to clear the user's cookies. And we can just go and update our error handler. So let's look up error handler. And in here, we get the request path. So let's add a check. We'll say if the request.path is equal to the refresh path, which we've defined in our cookies. If this is true, then we want to call the clear auth cookies utility function and pass in our response. So now all the cookies will be cleared when an error occurs on this path. And that's exactly what we want to do. Now let's give this a save and go back into Postman. And when we send this request, we should see all of our cookies cleared, and there they are. Now let's test another edge case. So we'll sign in with the user. And right now they have a valid access token and refresh token. Let's remove the access token. And in the refresh endpoint right now, they're able to keep refreshing their access token and it'll generate a new one here. We see that. And now let's delete all of the sessions in our database. So we'll go here and just delete these documents. Now we'll delete the access token. And if a user tries to refresh their access token using this refresh token, even though this token is valid, the session was removed from our database. So this should result in an error. And there we go. We see session expired and it's a 401 unauthorized. And now we should also see that the cookies are cleared. So this endpoint is finished. Now let's start working on this verify email endpoint. So this is going to be a request to the /auth/email/verify, and then we're going to pass in a code in the URL params. Right now, I just have it set to this random ID. And this endpoint is basically going to take this verification code ID. It'll look it up in our system. If it finds a record, it'll grab the user ID off of that verification code, and then look up the user and update their verified property to true. Then it's going to remove the old code and the user will be verified. So let's go back to our code and add this endpoint. Back in our routes file here, I'm going to add a new request. It'll be to /email/verify. And then we're going to pass in our code. Then we'll add our verify email handler. Now let's go and create this handler. Back in our controllers here, we'll export verify email handler. First, we want to validate the request. So let's get the verification code. That's going to come from the request.params.code, but we want to validate this with a Zod schema. So let's create a schema. We'll call it verification code schema, and we'll call the parse method. Let's add our code in. Now let's create this schema. We'll go back to the auth.schemas file, and down at the bottom, this will just be a Zod string with a min length of 1 and a max of 24. And this is based off the MongoDB object IDs. So these unique IDs in MongoDB, they can't be any greater than 24. So that's where these numbers are coming from. Now let's save this and import this schema. Now we know that this is a valid verification code, at least the length of it is. So now we validated the request and we're ready to call our service. Let's go back in our auth services file here, and we're going to export a verify email service. It's going to be an async function, and it'll take in a code, which is of type string. And in here, let's write out all of our logic. So we'll get the verification code, then we'll get the user by the ID from this verification code record. Then we'll update the user to set the verified equal to true. Then lastly, we'll delete the verification code and return the user. So now let's get this code. So we'll say const valid code, and we're going to await the verification code model, and we'll try to find one. In here, we need to pass it some filter criteria. So the ID property will be the code that's passed in from the parameters, and the type will be the verification code type dot email verification. And lastly, we want to make sure that the expires at is greater than the current date. Now let's assert that we found a code. So we'll call our AppAssert function, and for our status code, if we didn't find anything, we'll return a not found 404. And then for our message, we could just say invalid or expired verification code. Now, if we've made it past this check, then it means the code exists and we're ready to update our user. And I'm actually just going to remove this get step and do it in one step here. So we're just going to update the user, and if the update was successful, then we'll assume the user exists, and if it failed, then we'll return an error. So let's say const updated user is going to be equal to the user model, and we're going to call find by ID and update. And the first parameter will be the ID. We're going to get that off of the verification code record up here. We're going to use the user ID. Then the second parameter is the update we want to perform. So we want to set verified to true. And lastly, we want to pass a third option. We'll set new to true so that we get the new updated user here with the verified set to true. If we don't pass this, then we're just going to get the user record that was updated without these updates. Now let's close out this paren. And this user will either be the updated user or null. So now let's assert that they were updated properly. We'll pass in our updated user. If this failed, an internal server error, and say failed to verify email. Now we're ready to delete our verification code. So we'll just await valid code dot delete one, and this is going to delete this valid code document. And now let's return our updated user. So I'll return an object with a user property, and we want to omit our password. Now let's give this a save, and we'll go back out to our controller, and we need to call this method. So we'll say await verify email and pass in our verification code. Right now, we're not going to do anything with the response. We'll just return a 200. Then we'll return some JSON as well. We'll just have a message saying email was successfully verified. All right, so that looks good. Now let's import this handler in our routes file here. And we'll go back in a Postman and give this a test. So first let's open up MongoDB, and let's just grab our first test user. So they have an ID of 66401. And let's go into verification codes and just find that code. And we see it's this first record here. That's the user ID property. So let's grab this verification code ID and we'll go back into Postman. And in this value here, let's just paste in that user ID. So we'll hit send. We see email successfully verified. And if we check our users table, we should see verified is set to true. So that looks like it worked. And if we check our verification codes, we'll no longer see that user's verification code. That looks like it's all working properly. Now that the verification code process is working, let's actually send the verification email when a new account is created. We're going to be using Resend for sending our emails, and they make it really easy for us to set this up in our app. So if you go to their website and you click Get Started, you'll have to create an account with Resend, and then we'll take you through an onboarding process. And once you finish that, you'll get an API key. And if we go to their docs here and on their Getting Started, we'll see that they have a Node.js quick start. And here's the guide for sending emails in Node. So you'll have to create an API key, or you can even use the default one that's generated. And then you'll have to install the package. I already have it installed, but make sure to run this command if you don't. And then in the code sample here, you'll see that we just need to instantiate a resend client. We'll pass in our key, and then this resend client allows us to send emails by calling the send method. Then we'll pass in some email options, and this will all work with just these few lines of code. Once you've created an account, go to your dashboard here, and under API keys, you'll see all of your keys here. And you'll want to click in on one of these and just get this value, whatever it is. Once you have that value, then we need to create our resend client. So basically this line here. Let's go back to our app, and under our config folder, we'll create a new file called resend.ts. And in here, we want to create a new resend client. So we'll say const resend equals new resend. And then we want to pass in our resend API key. And we've defined that in our constants. And now let's just export this resend client. Now that we have this set up, let's create a utility function for using this resend client. Under utils, we'll create a send mail file. And in here, we'll export a constant called send mail. It's going to be an async function, and it's going to take some params. We'll destructure those in an object. We're going to get the to, the subject, the text, and the HTML. And these are all of the mail options that Resend expects. And we need to create a typing for this. So right above, we'll do type params. It's going to be equal to all of those properties, and they're just going to be strings. Now let's pass these params in as the typing. And in the body of the function, we're going to return resend. We'll import that in. Then we'll call the emails.send method. And now let's pass in our options. So they expect a from. And I'm going to use just one of the default resend emails, so I don't have to use a personal one and get that all verified. So the default resend one is this onboarding@resend.dev. That's the from email. And then we need a to email, and that's going to be equal to delivered@resend.dev. We'll replace these two in a second, but for now, just to get this working, we'll use the test ones. Then lastly, we'll pass in the subject, the text content of the email, and the HTML version of the email. So now let's save this file, and we should be able to just call it in our service. We'll go back to our auth service file, and then let's find our create account service. And right here, after we've created the verification code, let's call that send mail function. So we'll await send mail. Let's import that in. And in the parameters, we want to pass the to value. This will be who we want to send the email to. And that's our user.email property. And then we need to pass our text and HTML content for the email. as well as our subject. So we're going to have a few different templates like verification email and reset password email. So I'm going to create utility functions for getting the specified template, so we don't have to do it inline here. Under utils, let's create a new file called email templates. And in here, I'm going to paste in two functions. So we have a get verify email template. We see that the subject is verify email address. The text content is just saying click on the link to verify your email address, and then it's going to have a URL. This will be the URL that our API generates and the user will click on. And then this HTML content is just a bunch of HTML that's minified and applies some styles. And you can see here in this anchor tag, we have a link to that URL. So you'll see how this looks in a second. And right above, we have the password reset template. So we'll need that in the future. Now let's give this a save and use it in our function here. So we want to spread the result of that get verify email template. And in here, we need to pass it a URL. So let's create that URL above. We'll say const URL is equal to, then we'll open up backticks and add our app origin. That's going to be our front end URL. That's an environment variable. Then the path will be /email/verify and then the code, because this is the route that we've defined in our API routes file here. Now let's pass this URL to our function here, and that should all work now. Now let's grab the response from this function. So we'll destructure the response, and you'll see here that we get a data and an error prop. And this is going to be a name collision because we have data up there. So let's just remove that. And we're going to do a check. If there's an error, we're just going to log out the error. And I'm just going to ignore these email errors for now. So if we give this a save and create a new user, we should see that email in Resend. So we'll go back to register. And this time we'll add test4@test.com. We'll hit send. And we see that was successful. And if we open up Resend, you need to go to your dashboard. So if you just hit sign in here, that'll take you to the dashboard. And then you could go to emails, and it didn't get sent. And that's because I forgot to add the environment variable. So if I go back into my .env, my resend API key was invalid. So I'm going to replace this with my key, and then the email sender, I could just leave blank for now because we're using that default resend sender. So now I'll need to restart my API so that this key gets used properly. And now let's try to create another user. We'll have to do test5, and we'll hit send. And that was successful. So let's check resend now. And there we go. We see a verify email address. And if we open it up, we'll see here is how that template looks. And if we look at the plain text version, that looks like it's formatted properly. And now we get this ID. So if I copy this ID, I should be able to go back in a Postman and verify the email here. I'll paste in that ID and hit send. We'll see email is successfully verified. Now if I check my users, I should see that another user is verified. That test5 user verified as true. So it looks like that entire flow is working and our emails are being sent properly. Now let's refactor our send mail function so that we can use it in production and we don't have to send from this default resend email. Let's go back to our service here, and inside of send mail, instead of hard coding these values, let's make them dynamic. So I'm going to create some helper functions. First, I want to do get from email, and that's going to get the sender email. So this will be a function, and we want to check, is the node environment equal to development? If it is, then we want to use this value. So we'll add a ternary here. Otherwise, we want to use our email sender that's defined in our environment variables. So if you have a valid email with a custom domain, then you'll be able to use that in your .env file. Just make sure that in Resend, if you go to your domains here, make sure to get that set up and verified before you start using it in production. Now let's call this getFromEmail function here. And that's going to return the email that we're going to use. Then let's add our getToEmail function. And that's going to take in a string, which will be the to email or the recipient. And again, we're going to check if the node environment is development. If it is, then we're just going to use this string here. Otherwise, we're going to use the to value that was passed in through the parameters. So now we could just call this function, pass in our recipient, and then it'll select the right address to deliver to. Now this is dynamic enough to work well in production. Now let's start working on our next endpoint. So we'll open up Postman, and that's ForgotPassword. We'll see that it's a post request to /auth/password/forgot, and it sends a request body with an email property. And this will be the email that we're going to send the password reset email to. So let's go and add this to our routes here. Let's add a new line and add a post request. That'll be to /password/forgot. And then we'll pass in our send password reset handler. And this handler is just going to be responsible for getting the email from the body, verifying that it exists in our system, and then sending an email. So it'll be super basic. Now let's create this controller. Right below the email handler, I'll export a constant called send password reset handler. Now let's grab the email from the request. So we'll say const email is equal to the email schema. And I think I have to export that out of our schemas here. Let's export this. Now let's use it in here. We'll import it and then call the parse method, and then we'll pass in the request.body.email. So if this property was passed, then we'll get our email here, and we're ready to call our service. Let's go and create that service. Go down to the bottom and export a new function called send password reset email. And that's going to take in an email of type string. And now let's define all of our business logic. So first we want to get the user by email. Then we want to check if they're past the rate limit for sending emails. So we'll say check email rate limit, because we don't want to allow users to send infinite emails and just spam our endpoint. So we're going to implement some sort of rate limiting. So if it's a valid user in our system and they're not past the rate limit, then we want to create our verification code. Then we'll send the verification email, and then we'll just return our response. Now let's build this out step by step. So first let's grab the user, and we're going to get that off of the user model, and we'll call find1, then pass in our email. Then let's assert our user. We'll pass in our user, and then we'll say not found. And for the message, we'll set it to user not found. Now let's do our rate limit check. So the way we're going to do this is count all of the documents where the user ID matches this user and the type is of type password reset. And we're just going to allow 2 emails every 5 minutes. So we'll add an assertion that the count is less than or equal to 1. First, let's declare our rate limiting period. So we'll do 5 minutes ago, and that's going to be equal to a function 5 minutes ago. And let's just go and create this in our date utils here. We'll export a constant called 5 minutes ago. We'll let Copilot do that math. Now let's save this and import it back in here. Now let's count all of the verification code documents in our system. So we'll say const count is equal to the verification code model, and we'll call count documents. This is a nice handy method from Mongoose. Now let's pass our filter criteria. So inside, we want to check where the user ID matches our user from above, and the type is the verification code type .password reset. And lastly, we want to make sure that the created at is greater than 5 minutes ago. So basically, it's saying that this should be created at within the last 5 minutes. Now let's add our assertion. So we'll call app assert, and we want to assert that the count is less than or equal to 1. Since our rate limit is 2 emails every 5 minutes, if the count equals 2, then it means that they've exceeded that limit by trying to add a new email request. So it has to be less than or equal to 1. In that case, this will be the second email if there's already one found. So if this assertion fails, then we want to return a too many requests status code, which is a 429. And for our message, we'll just say too many requests, please try again later. So if they're not past the rate limit, we're good to create our verification code. Let's create our expiration date. So we'll set expires at, that's going to be equal to 1 hour from now, because this will be the reset password expiration date. We want this to be short just for security purposes. Now let's create this date function. We'll export const 1 hour from now, and we'll import it back in our service here. And now let's create our verification code. So we'll do const verification code, and we're going to call the model create method. In here, we'll pass the user ID, we'll set the verification code type to password reset, and then also the expires at date. Once that's created, we're ready to send our verification email. So first we need to grab our URL that we're going to send. So we'll do const URL. This will be equal to our app origin, then /password/reset, and then we want to add some query parameters. So we'll add a question mark here, and then we'll say code is equal to our verification code ID, and we'll add an expiration date. So we'll do EXP, which stands for expires, and we'll set that equal to expires at .getTime. So this will be the UTC millisecond value of when this password reset request expires. We'll be able to use this on the front end to display a message like link expired, because we'll know the expiration date. It'll also allow us to not send requests to the backend if the link is already expired, so it might save us some requests. Now let's send our email. So we're going to get the error, and we'll call await send mail. In here, we want to pass our to email, and that's going to be our user email from above. And then we want to spread the results of get password reset template. And then we're going to pass in our URL that we made above. Now just make sure to import this. It's not auto importing. Now we want to check that the email was actually sent. So we'll get the data here and run an app assertion. We'll assert that the data coming back has an ID, and this refers to the ID of the email that was sent, which comes from Resend. And if that fails, then we're just going to return an internal server error, and we'll pass that error in the message. So we could open up backticks here and do error.name, and then we'll do a dash and add the error message. If this was successful, let's return our response. And that's going to be our URL that is used to reset the password. And then we'll also return the email ID, and that'll be equal to data.id. Now let's give this a save, and we'll go back to our controller here. Now we want to call that service. So we'll say send password reset email, and then we'll pass in the email from our request. If no errors are thrown here, then we'll know that the email was sent and we could just return a successful response. So we'll return a 200 OK, and for the message, we'll just say password reset email sent. Now let's import this handler in our routes file here. And let's give it a test in Postman. So we'll go back in here, and the forgot password is test@test.com for the email. Now let's send this request. We'll see that the email was sent. And if we check resend, we should see that password reset request here. Now if I open this, we'll see that template. It's nearly identical to the verify template. And if we look at the plain text, here is our reset URL. So we have the path to /password/reset. Here's our code, and here's the expiration date. Now, when a user clicks on this link, our front end will navigate to this page and take these URL parameters and send it to our API. And our API is going to take this code and try to look up in our system a verification code of type ResetPassword with this ID. And if it exists, it'll update the user's password. And the front end is going to send that new password as well. So let's open up Postman and start working on the ResetPassword endpoint. So here it's a post request to /auth/password/reset. And in the request body, we're going to pass in the verification code, which we'll get from the URL in the email, and then the new password here. Let's go back to our routes file here. And at the bottom, we'll add a new post request, and it'll be to /password/reset. And this will be the reset password handler. Now let's go and create this handler. We'll export a constant called ResetPassword. First, let's validate the request. We'll say const request is equal to the ResetPassword schema, and then we'll pass in the request body. Now let's go and create this schema. We'll add it to the bottom here, and this is going to be a Zod object. It's going to have a password, which will match the password schema that we've stored in a constant above. And it's also going to have a verification code. And that's going to match the verification code schema right here. Then we'll close that out. And now we can import this schema in our controller here. Now let's call our service. First, we need to create it. So we'll go back to our service file here and export a constant called ResetPassword. It's going to be an async function, and we're just going to destructure the password and the verification code. Now let's create a typing for these parameters. So we'll say type ResetPassword params will be equal to the password and verification code, and those will both be of type string. And now let's pass this typing in here. Then let's write out all of our business logic that we need to do. So first, we're going to get the verification code. If it's valid, we'll update the user's password. Then we'll delete the verification code. And lastly, we're going to delete all sessions. So anytime that a user resets their password, it's just going to clear all of their current sessions so that they'll have to log in on all their devices that they were previously signed in on. First, let's get our verification code. So we'll do const valid code. We're going to call our verification code model. We're going to call find one, and we'll pass in the ID, which is the verification code from our parameters. The type will be password reset. And we want to make sure that the expires at date is greater than the current date, meaning that the code is not expired. Now let's assert that we found a code. So we'll run our app assert, pass in our valid code, and if we didn't find a code record, we'll return not found, and then we'll return a message saying invalid or expired verification code. If we found a valid code, then we're ready to update the user's password. So we'll say const updated user is equal to find by ID and update. We'll pass in the code's user ID, and then we need to pass in our updates. So we want to update the password field. And instead of passing in the password directly, we need to hash it. So we'll call that hash value function and pass in our password. Because on our user model, this built-in pre-save method doesn't work because we're updating the entity. We're not creating it. I could probably add a pre-update hook or something similar to that, but for now, I'm just going to hash the password like this. Now let's close out this paren and assert that the user was updated. So we'll pass that in. If they failed to update, we'll return an internal server error and we'll say failed to reset password. And now let's delete our verification code. So we'll await the valid code.delete1. So this should remove that record. And now let's delete all of our sessions. So we'll await the session model and we'll call delete many and we'll pass in the user ID. So it'll delete all sessions related to this user. Now let's return our response. So we'll just return our new user and we'll omit their password. Now let's give this a save and we'll go back to our controller here. Now let's call that service, which was ResetPassword, and let's import this. Now let's return our response. And as we return the response, I also want to clear all the auth cookies so that we require the user to sign in again after they've reset their password. So we'll call this clear auth cookies function. Then we'll tack on the status, which will be OK. And then we'll send a message of password reset successful. And we'll just close these out. So now their cookies should be cleared and it'll require them to sign in with their new password that they sent in the request. Now let's import this handler in our route file here. And we'll go back to Postman to test this out. So currently our user here, test@test.com, had a password of 123123. And I can log in with that password and we get our cookies. Now let's send a forgot password email. So test@test.com, we'll send that. Actually, we've already sent this email. So let's check the inbox and now let's grab this code here and let's just double check our database. So our users here, test@test.com, had a user ID of 6640. And if we go to verification codes and just look up that ID from the email, we'll see that's here. And the user is 66401. And that looks like it matches that user here. So let's just copy this code, go back into Postman, and on this reset password, I'm going to send that verification code from the email, and the new password will be 11111. So we'll hit send, and we see internal server error. So let's figure out what we did wrong. And it looks like we forgot an await somewhere. So let's go back through our flow. Reset password handler. So we'll go into reset password. So that looks correct. We're awaiting that. Then we try to get the user. So when we hash the password, we actually have to await this because this is a promise of type string. So we missed an await there. Now if we save, we should be able to go back into Postman, retry this request, and we'll see password reset successful. And now if I go and try to log in as test@test.com with this old password of 123, we'll see invalid email or password. And now if we update this to the new password, let's log in and we see login successful. So our whole reset flow is working and we have all the right emails being sent. So that concludes all of our auth endpoints here, and we're ready to start moving on to our user endpoint. And our user endpoint is just a GET request to /user. And our API is basically just going to read the access token from the cookies, try to validate it. If it's valid, it'll grab the user ID on it, fetch the user in our database, and then return that user. It's a pretty basic controller, but we're going to have to add some authentication middleware to decode the cookie and set the user ID on the request. So let's go back to our index file. We'll close out of all of these files here. And back in our server index file, we'll add our user routes. And these are going to be protected. So we'll say protected routes. In here, we'll do app.use, and then we'll pass in our /user path, and then we'll pass our user routes. But before we create our user routes, I want to create our authentication middleware. So then I can call authenticate, and every request that starts with /user will have to go through this middleware so that by the time we get to the user route, the user is already authenticated and we don't have to add any auth logic in our route. We can just assume that the user is valid. So let's go and create this authenticate middleware. Under the middleware directory, we'll create a new file called authenticate. And in here, I'm going to create an arrow function called authenticate, and it's going to take the request, response, and next functions from Express. Let's add the typing here. So it'll be of type request handler, and that comes from Express. And now when we hover over the request and response, we'll get that typing. The first thing we want to do is get the access token from the cookies. So we'll get that off of request.cookies.access token. And then we'll typecast it to a string or undefined. Now let's assert that the access token is actually passed in the cookie. So we'll do app assert, pass in the token. For our status code, we'll use unauthorized. For our message, we'll pass not authorized. And then we want to pass an app error code. And the error code will be invalid access token. If we made it past that assertion, then it means that the user had a cookie. So now let's try to decode that cookie and get our token payload. So we'll get the error or the payload, and that's going to come from verify token. And we're going to pass in our access token. So if you remember, in this function, we get a token and we return either a payload or an error. Now let's assert that a payload exists, meaning the token was valid. So we'll pass that in. We'll set the status code to unauthorized again. Then for the message, we want to check if the error equals JWT expired. If it does, then we'll just say token expired, and otherwise we'll say invalid token. And lastly, we want to pass the app error code again of invalid access token. We're going to use this error code back on the front end so that it'll trigger a request to the refresh endpoint and try to get a new access token. So if the payload is validated, then we'll know that it'll be of type access token payload, and we have access to the user ID and the session ID. And we just want to set those two properties on the request object here so that when it gets to our handlers here, we can call something like request.userid, and that's going to be the user's ID from this token payload. So let's assign those properties. We'll do request.userid. That's going to be equal to the payload user ID. And likewise, we'll set the session ID. And that'll come from our payload.session ID. Then after we set those properties, we want to call next so that the request will be passed on to our controllers. Now, TypeScript is giving us an error saying user ID does not exist on type request. And that's happening because this request handler sets the express request to the default express request typing. And that default typing doesn't have a property called user ID or session ID. And so it's telling us that we can't set these properties because these properties don't exist on the request typing. Now to get around this, you could either add an @TSIgnore and that'll fix it, but that's usually not a great idea, especially not in production. So the way to get around this is to basically tell TypeScript that these custom properties will actually exist on the request object. To do that, we need to create a file in our backend directory at the root of our project, and we'll call it index.d.ts. This is the declaration file for our types. And I'm just going to paste in some code here. So we're basically adding on to the global express request typing and adding these properties to the typing. So now if we save this, it should get rid of all of our errors, because when we go back to our request here, we'll see that this user ID can be of type object ID. And that's because we've extended the global express request and added these custom properties. So now we're able to use the user ID and session ID. We'll go back into our Authenticate middleware and make sure to export this out at the end. And one thing to note is when you do something like request.userID, TypeScript won't tell you that this could be undefined, because if we do this log all the way up here, then we'll see that TypeScript won't tell us that it could be undefined, because we've told TypeScript that it will always be defined here. So you can either make this optional, so do something like or undefined, and then you'll get that typing here. But then in your controllers, you'll have to assert that this value exists. So basically doing an app assertion, making sure that the user ID exists, and then you're safe to use it later down in the lines below. I'm not going to use that approach. I'm just going to keep it as a string because I know that it's always going to be there if it passes this authenticate middleware. And I'm only going to be using it in my controllers that have this middleware. But that's just something to be aware of, because we're kind of bypassing the typing here by telling TypeScript that these properties will always be there, when in reality they may not always be there. So for now, we're going to keep it as it is, and let's import this middleware back in here. And now we're ready to create our user routes. So let's find our routes folder and create user.route.ts. And here we'll declare our user routes. That'll be a new router from Express. Then let's add our prefix. It'll be /user. And then we'll add a GET request. And the path will just be the root path at /user. And here we'll pass a getUser handler. Now let's create this handler. Under controllers, we'll create a file called user.controller. We'll export a constant here, getUserHandler. We'll wrap it with the catchErrors function, and it's going to be an async request handler. Now we need to fetch the user from our database. In this case, we don't need to validate the request because we've added this authenticate middleware. So we know that this request will always have a user ID, and therefore there's nothing to validate. We also don't need a service because we're just making one query to the database to get the user and then returning it. So there's no extra business logic or complicated code that needs to go on. Therefore, it's not necessary to create a service. So let's try to get that user. We'll call await user model dot find by ID, and then we'll pass in the request user ID. Now let's do our app assert. We'll pass in our user and we'll return a not found with a user not found message. And if the user was found, we'll just return a 200. And in the JSON, we want to call user.omitPassword so that we don't send the password back to the client. So that looks good. Let's go back to our route file and import the handler here. Now let's export our user routes so we can use them in our index file here. Now let's give this a save and try to get our user in Postman. So let's double check that I have cookies and I don't have an access token. So let's go and refresh my token and you'll see that our API is crashing. Let's look at these error logs. So it's saying property user ID does not exist on type request. So this was the same error that we were getting in our authenticate middleware. So here, when we were trying to set this user ID, we were getting this error. And the problem that's happening is our TypeScript server in VS Code here acknowledges that the user ID will be set because we have this declaration file at the root. However, when we're running our local dev server, we're actually using a different package. So in the package JSON, you see that we're using tsnode-dev. And this package isn't aware of our declaration file here, so it doesn't know about these properties. So to get around that, we can just pass another file here to tell this package about this index declaration file. So at the end, we'll just do index.d.ts. Now, if we save this and restart our server by doing npm run dev, then that error should go away. Now let's minimize this. We'll try to refresh our token. So access token refresh, let's verify that we got that. And now in our user, let's try to get our user. And here he is. So that looks good. Now let's start working on our session endpoints. So we have a GET request to /sessions, and this should just return all of the active sessions in the database for the given user. Let's go back to our index file here, and let's close out all these other files. And down below our user routes, let's declare some new routes. This will be to /sessions, and we want the authenticate middleware to run. These are going to be our session routes. Now let's create these routes. Under the routes directory, we'll create session.route.ts. And in here, we want to create our session routes, which will be a new router. Then we'll add our prefix. It'll be /sessions. And now let's attach a GET request. So we'll do sessionroutes.get. And this will be the GetSessions handler. Now let's create this handler. In our controllers, we'll create session.controller.ts. And in here, I'm going to export a handler called GetSessionsHandler. We're going to wrap it with the catch errors utility function, and it's going to be an async request handler. So now let's make the database query to get all of our sessions. We'll do const sessions. It's going to be await the session model, and then we're going to call the find method. Let's make sure to import this. And now let's pass it some criteria. So we want to get all the records where the user ID equals the request user ID. And this is going to come from the decoded access token. And we only want to get the valid tokens. So we'll say expires at is greater than the current date so that it won't return any expired sessions. Now let's pass a second parameter here. And this will be an object of all the properties that we want to return. So the only properties we care about are the session ID. We'll set that to 1, which basically tells Mongo to return this property. We also want the user agent, and then we want the created at. So we can tell the user which device that session was created on and when it was created. Now the third parameter that we want to add is the options, and we can add a sort here. And we'll set that to created at descending so that it returns the newest sessions first. Now let's format this code here. And right after we get the sessions, let's return our response. We'll send back a 200 OK. And then in the JSON, I want to add on an extra property. So instead of just returning the sessions as is, I'm going to map over them. So I'll say sessions.map, and for each session, I'm going to return a new object. And here I'm going to spread the results of session.toObject. And this is just going to return a JavaScript object that we then spread in this mapper. And then I want to add a custom property called isCurrent so that we can tell the client which session is the current session that they are logged into. So let's spread the results of this ternary operation. So we'll check, is the current session that we're iterating over, is that ID property equal to the request.sessionID? So if that's the case, then we want to display return an object with isCurrent set to true. And now let's close out all of our curly braces. And now when we return the sessions, we'll get each session plus this isCurrent property. And this is only going to be set on the session that matches the current request session ID. This will be used back on the front end so that the user can only delete sessions that are not the current session. So let's give this a save and import the handler back in our route file and then export these routes. Then import them back in on our index file. And now we should be able to see these sessions in Postman. So if we make a request, we'll see a session there. And now if I log in again, then I go to the sessions, I should see both of those sessions, and there they are. And we'll see that the isCurrent is only on the most recent session. So that looks like it's working properly. Now our final endpoint is this sessions delete endpoint, which will be to /sessions/ID, and this will be the ID of the session. So our API will just parse the ID and try to delete that record from the database. So it's a super basic controller. Let's go back to our session routes here, and we'll define a new route here. We'll call it delete. And then we want to pass in an ID. So this is a dynamic URL parameter. Then we'll pass it the delete session handler. Now let's create this handler in our session controllers file. We'll export this constant and just add our boilerplate code here. And in here, I want to grab the session ID, and that's going to be equal to a Zod string. Let's import Zod. Then we'll call the parse method and pass in the request.params.id. And this is ID because we called it ID in this parameter here. So now that we're validating the session ID, let's try to delete the session from our database. So we'll say const deleted is equal to the session model dot find one and delete. And then we're going to pass it our filter criteria, which will be the ID of session ID and the user ID. So you may be wondering why we even need this user ID. Well, if we don't have this check, then anyone can make a request to /sessions and then pass in a random session ID. And if we don't add that user check, then any user will be able to delete any session. So we want to make sure to have that check for the user ID. Now let's assert that the deletion was successful. So we'll add our app assert, we'll pass in deleted. For our status code, we'll just say not found. So whether the session ID was invalid or the user didn't have access to it. Then for our session, we'll just say session not found. Lastly, we'll return the response with a 200 status code and session deleted. We'll call it session removed. Now let's import this handler in our routes file. and we'll test out the session deletion. So we'll go into Postman, and in our sessions, let's just grab this ID, or let's grab the other session that's not current. And in here, we'll paste that in. We'll hit send. Now we see session removed, and if we query for all of our sessions, we should only get back our one current session. And now if I take this ID and log in as a different user, like test2, I need to set back the password to the original one. Now I go to the delete endpoint and try to delete another user's session. This should fail, and we see session not found. So it looks like our endpoint is working properly. And that about wraps it up for our API. Before we start working on the front end, I want to add a build script that's going to compile our TypeScript code to JavaScript, and then a start script to start our server from the compiled JavaScript. To do that, let's open up the package.json. We'll go all the way to the bottom, and right below this dev script, let's add another script called build. And this is going to call TSC, or the TypeScript library. And by default, it's going to check the root directory and use this tsconfig.json to compile our TypeScript. And in this tsconfig, we've specified the outdir to be dist. So it's going to compile all of our JavaScript to a dist folder on the root directory. After we've created the dist folder, I also want to copy this package.json so that our compiled code knows which dependencies it needs to run. So right after this TSC, I'm going to add a double ampersand and do the copy command. And I'll copy the package.json into the dist folder. Now let's add a start script, and that's going to be equal to node index.js. So this script will run when we're trying to start our compiled API. Let's give this a save and then try to build our project. So we'll do npm run build. And it looks like that built successfully. So if we scroll up, we'll see a dist folder, and here's our index.js. And this looks a little bit different because of the whole TypeScript compilation process, but this is essentially our entire API in JavaScript. Now you might be wondering why the start command is just node index.js instead of dist/index.js like this. And the reason for that is when this script gets run, since this will be our compiled code, the root directory is going to be this dist folder. So this will be our new root directory, and when we call node index.js from this package.json, it's going to grab this index file. If we added the dist folder here, it's going to then look for a dist folder inside of this directory, and it's not going to find it. That's just one thing to be aware of. If you want to try to run this locally, you could just do node dist/index.js, and that should start up our server. And this is running our JavaScript code here. So that wraps it up for our API. Now we can start working on our front end. Let's begin by splitting our terminal here. And I'm going to use this left terminal to run our front end. So I'll go back out of directory. So we're at the project root here. And I want to create a front end folder. To do that, we can run a command from npm. And if we go to the v.js docs and click on getting started, we'll find that start command down here. So we could run npm create v@latest and then pass in a template. So let's copy this command and we'll go back into our terminal here, paste that in, and then let's change this name. Instead of my view app, we're just going to call this front end. And then for the template, instead of view, let's pass React. Then we'll run this command and it'll ask us a few questions. So we want to install create v. Now that generated this front end folder with some default starter files. Now let's change into that directory. Then we'll run npm install to install all those dependencies. You can see here are the dev dependencies, and we just have React and React DOM. Now let's close out all of these files from our backend and collapse this folder. Let's also start our API server. so that our front end can talk to it. Now let's delete all of these starting files that we don't need. So we'll get rid of this index.css and the app.css file. We can also remove this assets folder. In our main.jsx, let's remove this import here. And then in our app.jsx, let's get rid of all of this starting code. We'll just add test for now. We'll get rid of this state. And then let's get rid of all of these imports. Now let's hit save and try to run our front end. To do that, we'll do npm run dev, and that should serve our app on localhost port 5173. And here we see test. Now let's add all of our providers that we're going to be using in our app. So first we want to add our browser router, which comes from React Router. So let's install React Router. We could do that with npm install react-router-dom. And once that's installed, let's wrap our entire app with the browser router. So we'll open up curly braces and add our browser router. And we'll wrap our app component. Now let's just import that. Now we need to go into our app component and add our routes. So instead of returning this fragment, let's return a routes component. And inside, we're going to define all of our routes. So first, I'll just create an index route that's temporary. We'll use the route component, set the path to just the route path, and then we'll add a dummy component for now. I'll just create this above. So now we have our first route defined. Let's go back to our main.jsx, and now let's add our query client provider. We're going to be using React Query on the front end, so let's install that as well. We'll do npm install @tanstack/React Query, and then we're also going to install the DevTools so we can see our queries in the browser and manage them. So we'll run this command. And once that's done installing, let's go back to our app here, and right below our app component, we're going to add our React Query DevTools. Then we'll set the initial state to be false so that it's not open by default. Now let's import this at the top. And let's also set the position to bottom right. And this import isn't correct. Let me just fix that real quick. Now we should get this component. Now let's wrap our browser router with the query client provider. So we'll go up here and do query client provider, and that comes from tanstack/React Query. And in here, we need to pass a client, and that's going to be a query client. Then let's wrap our browser router and all of its children with this query client provider. Next, let's create this query client. Under the source folder, we'll create another folder called config, and inside there, we'll create a file called queryclient.js. Let's declare our query client here, and this is going to be equal to new query client, and that's going to come from tanstack query. And now let's pass some default options. So we'll say default options, and we want to set the queries, and on there, we'll set the retry to false, so that it's not going to automatically retry our requests. Then let's export this at the bottom, and we should be good to import it back in our file here. Now the last provider we need is our Chakra provider. So let's go to their docs real quick. Then let's click Get Started here. And let's just copy this command here, which will install all of the Chakra dependencies. Once that is installed, let's go down and look at the example code. So we just need to wrap our entire app with this Chakra provider. Let's go back and add that in. So right above our query client provider, let's paste in the Chakra provider and then move all of these components to be inside the Chakra provider. Then let's import that at the top. And in the provider, we need to pass a theme prop, and this is going to be a custom theme. Let's go and create this theme. So under source, we'll create a file called theme. And inside that folder, we'll create a index.js file. And now I'm going to paste in our Chakra theme. So this is just a basic theme with a few component customizations and some colors that we're going to be using throughout our app. We have a primary color, a primary dark, and then a text muted color. I also added some config options to always use dark mode, regardless of the user's preference. And these custom component themes are being imported in. So we need to create these files. I'm going to paste those files in as well and just quickly go over them. So in our button theme, you'll see that I define a primary button here with these custom styles applied. And then I default the button props to be that primary variant. In our link theme, I just set the base color of every link in our app to be this light blue so that we don't have to apply this color on every link. Now let's give this a save and import this theme back in our main.jsx. And now we should be good to save and restart our app. So we'll run npm run dev, and we'll go back to our browser here. And when we refresh, we see our theme being applied, and here are our dev tools. Right now we don't have any queries, but we'll see those in here once we add them. Now let's start building out our views. We'll start by building out our login page. So let's go back to our app here, and we'll add a new route. The path will be /login, and the element is going to be the login component. I'm going to store all of these views or routes in a folder called pages. So under source, let's create that pages folder. And inside, we'll create a file called login.jsx. Now let's create our login component. Instead of returning this div, I'm going to return a flex component. That's going to come from Chakra. And I'm also going to add some styles to it. So we'll give it a min height of 100 VH and align all of the content in the center. Then I'll add a container, which will be centered with a max width of medium with some padding and the text align set to center. Now let's add our heading, and we'll set the font size to 4XL, and we'll give it a margin bottom of 8 units. For the content, we'll just say signed into your account. Below that, we're going to add a box or a div with some styles applied to it. It's going to have rounded corners and a slight box shadow. And inside that, we're going to add a stack to hold all of our form fields. And we'll set the spacing to 4. Now let's create our email input. So we're going to use a form control component. We'll set the ID to email. And inside, we're going to have a form label, and that'll be email address. Below that, we'll have our input. It'll be of type email. Then let's add some more props. We want to set the autofocus prop so that it automatically focuses on the email input. And now we need to give this a value. We're going to store the input value in some state. So let's go up above the return statement and add our email field in a use state hook. We'll call it email and then set email. And by default, it's just going to be an empty string. And let's do the same thing for the password because we're going to need an identical piece of state. We'll default that to an empty string as well. Now we can take this email state and pass it in as the value. And now we need to add our onChange function. So this will fire every time the user types in the input. We're going to want to get the event and call set email and pass in the event target value. So this will update our state with whatever the user is typing. Then let's make sure to import our useState hook from React. Now let's copy this form control and create our password field. So the ID will be password, and so will the type here. For our label, we'll just say password. Let's get rid of this autofocus prop, and our value is going to be password from our state, and this will be set password. Now let's give this a save and see how this looks in our browser. So we'll go back to our app component, import our login component, and then we'll go to /login. So that looks good so far. Now let's add a link here to ask the user if they forgot their password, and that'll take them to the Forgot Password page. And then we'll add our sign in and sign up buttons. Let's go back to our code, and in the login component, right below this password form control, I want to add a link. And this is going to be a Chakra link, and we're going to have to rename the import because there's going to be a name clash with the React router link. So let's go to the top, and from Chakra, we want to import the link component as a Chakra link. And right below that, we want to import the link component from React Router DOM. So using the Chakra link will just allow us to use these Chakra style properties to style the React Router link component. Let's go back down to our Chakra link. And in here, we want to pass an as prop, and that's going to tell Chakra to render this Chakra link as the React Router link. Then we need to pass the to prop, and that's going to be to /password/forgot, and we'll create this page later. Then let's give it a font size of small and add some responsive styles. So for the text align, we want the base style to be center. So this is going to be the style that applies on mobile. And then for screen sizes small and higher, we're going to set it to right. So on bigger screens, it'll be right aligned, and on mobile, it'll be center aligned. Now let's close out this link, and we'll just say forgot password. So that looks good. Now right below that, let's add our sign in button. So this will be a button from Chakra. We'll give it a margin Y of 2 units. And we want it to be disabled when there's no email or the password.length is less than 6, because we don't want them to be able to submit this form until they filled out all the fields and have our minimum password length. Now let's add the children for this button, and that's just going to be sign in. So let's give this a save and see how that looks in our browser. So now we'll see that the button's disabled, but once we add some content to these fields, that becomes enabled. And if we click this link, that'll take us to /password/forgot. Now the last thing to add is to have some sort of text here that allows the user to sign up if they don't have an account. So let's go back, and right below this sign in button, we'll add a text component. Let's set the alignment to center. Font size will be small, and the color will be text.muted. And this color is coming from our custom theme, which we defined in this index file. We have our colors, we have a text property, and then this muted field. So this is the color that we're going to use. Now let's add the text content. So we'll say, don't have an account. Then we'll display another Chakra link. So we'll say Chakra link as link to /register. And for the content, we'll just add sign up. Now we're getting an ESLint error here, and it's saying that this apostrophe can be escaped. So let's just copy this code here and replace the apostrophe. So that should make ESLint happy. Now let's give this a save and check it in our browser. So now we see don't have an account and the sign up link, and that takes us to the register page. So this looks good. Now let's add the actual submit functionality to our API. So when the user fills out this form and hits sign in, this should make a request to our /auth/login endpoint. To do that, we'll use React query, and we're going to use something called a mutation to submit the form and then trigger an action on success. So let's go back to our code here, and we'll go up to the top, and we need to create our mutation. So I'm going to destructure some properties from use mutation. That's going to come from tanstack query. And when we call this hook, we need to pass it some config. So first we need the mutation function, and this will be the function that runs when we call the mutation. So this needs to be our API call to the backend. In order to call our API server, we need to create a client, and we're going to use Axios to make HTTP requests. So first, let's install Axios. We'll close out of the server and do npm install Axios. And once that's installed, let's go into our config folder and create a new file called apiclient.js. In here, we're going to create an Axios instance. So we could say const API is equal to axios.create, and then we'll pass it some config. Let's import Axios at the top. And now let's define our options. So we'll say const options will be equal to the base URL. We want that to be our API URL. And if you look at the sample env file that I have in the finished code here, we'll go to the front-end directory and then the sample env. Let's just copy this file and create our own .env. So at the root directory of our front end, we'll create a .env, and we'll just paste in that value. So we're just setting the API URL, and we're going to set that to localhost on port 4004, because that's what our API is running down here. So if your API is running on a different port, just make sure to update that. So now to use this environment variable, we'll go back to our client, and we need to call import.meta.env, and then pass in our environment variable, and that's the API URL. So this is just the way that we use environment variables in Vite, so this may look a little different than what you're used to. Below this, we're going to add with credentials, and we're going to set that to true. So this is just an option that we're going to need when we're making authorized requests to our backend. Now let's pass in these options to our Axios create function. And this function will return an Axios client or an Axios instance, which we can use to make requests to our backend. So let's export this at the bottom. Now let's add our response interceptors. So we'll say api.interceptors, and then we want the response interceptors. And when we call use, we need to pass it two functions. So one interceptor that's going to run when the promise resolves successfully, and then another interceptor when the response throws an error or when the promise is rejected. So these interceptors allow us to modify the response coming back from the API or format the response a specific way. So if you've ever used Axios before, you'll notice that the default response is this giant Axios object, and on that response you have a data property. And usually you have to do something like response.data every time that you get a response. Now, instead of doing that, we can just use an interceptor so that anytime we get a successful response, we're not going to return the entire Axios response. We're just going to return the response.data because this is the only part that we actually care about. Now let's add our error interceptor. So if an error is returned, then we need to pass a function that intercepts that error and formats the error that's thrown. Let's open up the body of the function, and I want to destructure a few properties. So we're going to get the error.response, and this will be our API response. And off of that, I want to grab the status that it returned and the data that it returned. So this would be the response body. Once I have these properties, I'm going to return a new promise rejection, and I'll pass in the status and then spread the data. So now anytime an error is thrown, when we check the error object, we'll always have an error status, which will be the HTTP status code, and then we'll also have any properties that were returned from our API. For example, if we go back to our error handler, in here you'll see that on some of our responses, we attach an error code or a message. So these data properties will be accessible on this error object here because we're spreading those properties here. So this will just make it nicer in the UI because we won't have to do something like error.response.status or error.response.data. Now let's create our login function that's going to use this API client. Let's collapse this backend folder, and under source, I'll create a new folder called lib. And inside that, I'll have an api.js. And this is going to hold all of our API calls to our auth server. First, let's export a login function. It's going to be an async function, which will take some data as a parameter, and it's going to return the API client that we just created. Then we're going to call the post method, and the path will be to /auth/login, and then we'll pass the data in the request body. Now let's copy this function and use it back in our login component. So the mutation function will be that login function. Next, let's add an onSuccess handler. So if the login is successful, we want to run a function. So we'll add an arrow function in here, and we want to redirect the user to the home page or the authenticated view. To do that, we can call the navigate function. To get access to this navigate function, we can go above and do const navigate is equal to use navigate, which is a hook from React Router. So this will just return a navigation function that we can call to send the user to a different page. The first parameter will be the path, so we'll just say the root route, and then I want to pass some navigate options, and I'll set replace to true. And this basically just replaces the current item in the browser history stack so that when they're redirected to the home page, if they click back, they won't go back to the login page because it has been replaced. And that's usually what you want to do with login forms or create forms because you don't want the user navigating back to those pages after they've been redirected. Now this useMutation hook returns a bunch of properties. And you can see we have the mutate function, we have a status, and a few other properties. So let's grab the mutate function, and we'll rename this to sign in. Then we'll grab is pending to see whether the mutation is pending or not. And then we want to check if the mutation threw an error. So we'll get the isError property. Now let's update our components to use these properties. So first we'll grab this error, and right above our stack here that displays all of our fields, let's check if there was an error. So if isError is true, then we want to output a box component. We'll give it a margin bottom of 3, and we'll set the color to red.400. Then inside, we'll just say invalid email or password. So that should handle our error state. Now let's use our sign in function. So we'll scroll down to our button right here, and we'll add a new property. It'll be onClick. We're going to pass an anonymous arrow function here. It's just going to call sign in and then pass in our email and password that's in our state. So when this function is called, this mutation, it's going to run our mutation function, which is login, and whatever we pass in these params is what's going to run when we call sign in. When we call login here, that's that data that will get passed in. So you could think of it as anytime we call this mutation, it's going to call whatever mutation function we passed in. Now let's add our loading state. So we'll grab this isPending flag and go back to our button. And we want to set the isLoading property. And that's going to be true if isPending is true. So that's going to display a little loading spinner and disable our button. So when we click this button, it'll submit our form. But I also want to submit the form when the user clicks enter and they're on the password field. So that'll just give them a nice user experience. So let's add another event listener here. We'll do onKeyDown, and this is going to take a function. we'll get the event and the parameter, and we want to check if the event key is equal to enter or the return key. If that's true, we'll do this double and then we'll call the sign-in function. So if they hit the enter key, we'll run our sign-in, and that should make the request to our backend. After the request completes, then we'll either be navigated to the home page on success, or if there's an error, we'll see that error message in our form. So let's give this a save and restart our front-end server, and we'll give this a try. I just realized I made a typo here, so we want to make sure that says invalid. Now we'll go back to our login form, and let's try to sign in with the user. So let's go back into Postman, and I'm going to grab this user, so test2 at test.com. I'll paste that in here, and then the password is 123123. And I'm actually going to mess this up for now, just to test our error message, and we see that there. And now let's add a valid email and password, and we get signed in and redirected to the home page. So our login form looks good, and when we try to go back, we can't go back. Now let's create the register form. It's going to be nearly identical to the login form. So we'll go back to our app file, and we'll call this register. And then the path will be /register. Now let's open up our pages folder. We'll create a new file called register.jsx. In here, we'll create a functional component. And now I'm going to split this login component on the side so that we could copy and paste a bunch of this code. First, let's grab all of this state and this mutation. And let's just bring it over to our register component. Let's also grab all of these imports because we're going to need a lot of them in the register component. Then let's rename this mutate function to be create account, and the mutation function is going to be the call to the register endpoint. So let's duplicate login. We'll call this register. And then for the path, instead of /login, it'll be /register. Now we should be able to import the register function. So that looks good. Now let's start copying over our components. So I'll copy from this flex container and the box and just replace this div. Now let's close out this container and move all this content to be inside of that. Then we also need to close this flex container and move all of this content in. Then let's close out this box here. And that should clear all of those errors. Now, instead of sign into your account, this should be create an account. And for our error message, I want to actually get the error message from the server. So I'll say error.message. And if there's no error message, we'll just say an error occurred. Now let's grab this error off of the mutation. So right after is error, we can actually get the error itself. Now let's create our fields. So I'm going to use this same stack here and the two input fields. So I'm going to grab all of that content. And right below our error message, I'll paste it in. Then we need to make sure to close this stack. This code will be the exact same, except instead of sign in, we want to call create account. We'll pass in email, password, and we also want to pass in the confirm password. So let's go add that third piece of state. We'll duplicate password, and we'll just make this confirm password. And then we'll set the function to set confirm password. Now let's create an input for this confirm password. We're just going to duplicate this form control element, and the ID will be confirm password. The label will also be confirm password. Let's update this value to point to that new piece of state, and then we'll pass it into the create account function. Let's also add some helper text underneath the normal password input to tell the user that it has to be at least 6 characters long. So we'll just add a text component, we'll make it muted, and then some helper text saying that it should be at least 6 characters long. Let's also remove this onKeyDown function because we don't want it to be on the password since the confirm password is the last input in the form. So we have that here. Let's also update this to set the confirm password state. Now let's create our submit button. So underneath this form control, let's scroll down and grab this sign in button. We'll paste that in. Then we'll replace the sign in function with create account. And we also want to pass the confirm password. Then let's add an extra check for our disabled state so that we'll keep the first two. But we also want to disable the button if the password doesn't match the confirm password field. So that's going to do the validation client side before it even gets to the server. Next, let's change this text to be create account. And at the bottom, we'll output this similar helper text, which allows them to go back to the login page if they already have an account. So we'll say already have an account. And if they do, we'll add a link with sign in. And that'll take them to the /login page. So let's give this a save, and we still have an error up here. We'll remove that import, and this looks ready to go. So let's go back to our app file, import this component in, and we'll give it a test in our browser. So let's go to /register, and in here we need to create a new user. So let's check our users table, and we have test5. So I'll create a test6 user, update that email, and then I'll use the same password, 123123. And you'll see when these passwords don't match, this button's disabled. And I'll add the correct password. We'll try to create the account, and we get redirected. So it looks like it all went through. And now if we check resend, we should see that new email that was just sent. So we have verify email address less than a minute ago. And here's our email to verify test user 6. Now let's create a page that gets rendered when someone clicks this verify email address button. So if we look at the source, you'll see that there's a link to /email/verify and then our ID. So when the user clicks on this link and opens it in their browser, it's going to render a page in our app. We're going to parse this code, and then our front end is going to make a request to the API and pass this code in the request. Then it'll just display the error or success response from the server, and the user will be able to tell if the verification was successful. So let's go and create this email verification page. Back in our app file here, we can get rid of this login pane. We'll duplicate that route and we'll say /email/verify. And then we want to pass in a dynamic URL parameter. We'll just set that to code. And that's going to be the verification code. For our element, we'll just call it verify email. And now let's create this page. So under pages, we'll create a new file, verify email. And here we want to return a flex component. We'll set the min height to 100 BH and then center the content. Inside of that, we'll have a container that's centered with a max width and some padding. Now let's add our loading, success, and error states. So first we want to check if the request is pending. And to do that, we need to call the useQuery hook to make a request to our API. So let's go above and call the useQuery hook. So we'll say useQuery, and that'll come from TanStack. And now we need to pass it a config object. And the first property we need to pass is the query key. And that's going to identify this query uniquely across our app. Let's pass email verification. And then we need to add a second parameter to our query key so that it can differentiate between different email verification calls. So to do that, we need to pass the code that was in our URL parameter here. So let's just pass code here, and we'll grab the code in the line above. We can do that by getting the code from useParams, which comes from React Router. So this returns an object with all of our URL parameters, and then we'll destructure the code. After the query key, we need to give it a query function. And this is going to be the function that runs when the component renders. Let's go back to our API file here, and we'll export a new function called verify email. It's going to be an async function that'll take in a verification code, and it's going to return api.get, and the path will be /auth/email/verify, and then the verification code. So this is the full path that we defined in our auth.route file right here. So we want to make sure that that matches. Now let's import this function back in our verify email component. And in here, instead of just calling it like this, we need to create a wrapper function. And now when this component renders, it's going to grab the code from the params and then run our query function. Now let's grab the return values off of this query. So we could destructure those in an object. And if you hit Control Space, you'll see that there's a bunch of these properties that are returned, which gives us information about the query. Let's grab the isPending property. We'll grab isSuccess and then isError. Back in our container here, let's check isPending. If this is true, then we want to output a spinner. That's a built-in component in Chakra. Otherwise, if it's not pending, we want to output a vertical stack. So we'll do vStack. We'll set the align to center and give it a spacing of 6. Inside the stack, we want to handle both success and error states. So we'll display an alert, and the status will be dynamic. So if isSuccess is true, then we want the status to be success. Otherwise, it'll be error. Then we'll set a width of fit content and a border radius of 12. Inside the alert, let's display an alert icon, and then we'll add some text. So if it's successful, then we want the text to be email verified. Otherwise, we'll say invalid link. So let's save this and format the code. Now let's add some extra text if an error occurred, because this is just going to be the alert title. So let's check if isError is true, then we'll output a text component. We'll give it a color of gray.400. And inside we'll add our description. So we'll say the link is either invalid or expired. Then we'll add a link to go back to the password forgot page so they could request a new password reset. So right below, we'll add a Chakra link. And we'll say as link. This will be the React Router link. We want to set the path to /register. Then we'll pass the replace prop. And for the text content, we'll say get a new link. Now let's import this Chakra link and the React Router link. Then the last thing we need to do is below this text, we want to render a link to go back home. So we'll just say another Chakra link to the root route to go back home. And this is going to render on both success and error states. So we don't have to add any conditional rendering. So this looks good. Let's give this a save and import this page in our app file here. And now we should be able to test this out. So let's go to our browser and we'll copy this link. and we'll go back to our app here and just paste this in. And before we hit send, I'm going to open up the network tab. So we'll be able to see our requests here. I'll minimize this a little bit. And now when I paste this link in, we see email verified. And if we look at our fetch calls, we'll see that we made a GET request to /auth/email/verify. And we passed in that ID from our URL. And in the response, we got email was successfully verified. And here we see that success message. Now let's check our database. So if we find this test 5 user, we'll see verified is true. Or we actually had test 6. So test 6 and verified is true. There we go. So that worked. Now if I refresh and try to use the same link, then we'll see invalid link, and then the link is either invalid or expired. We can either get a new link or go back home. Now I want to show the loading state. So let's copy this link again, and I'll paste it in here. Then in our network tab, I'm going to set the throttling to fast 3G. So we'll be able to see our loading state for a second. So we'll see our app loads in, and we have our loading spinner and then our error state. So that all looks good. So now if a user clicks get a new link, it takes them to /register, but it should actually take them to the /password/forgot page. So let's quickly update that. Back in our register component. Back in our verify email component. Get a new link should be /password/reset. And we haven't built this out yet, so let's go and build out that page. Back in our app component, let's create a new page, and this will be a forgot password page. And the path will be /password/forgot. Now let's create this page component. We'll call it forgot password, and we'll create an arrow function here. Now let's copy the same form components as we used in our register component. So I'm going to grab this flex container, the heading, and this error state. So let's bring this over to our forgot password. And then let's close out all of these tags. First, we'll close the box and then the container. Then lastly, the flex component. Now let's import all of these components. And I'm just going to copy all of the imports from here, and then we'll delete the ones we didn't use. Let's update this text to be reset your password. And we'll comment out this block of text for now so we can get rid of that error. Now let's build out our form input. So we'll create a stack with a spacing of 4. And inside we want to add our email input. So I'm going to grab that from the register component. Let's grab this form control and we'll bring it in here. Now we need to bring in the state for the email. So let's copy that over as well. Then right below this form control, let's add our submit button. So we'll say reset password, and it'll be disabled when there's no email in the input, and it has our loading state, and then it's going to call send password reset, which will be a mutation function. Then below all of this content, I want to add some helpful links. So the user will be able to go back to the login and we'll say sign in, or they could go back to the register, which is sign up. So that will just allow the user to navigate to one of those if they need to. Now let's create our mutation because our editor is complaining here that is pending is not defined. So right below our state here, we'll call use mutation, and we need to pass it a mutation function. This will be equal to send password reset email. Now let's create this function in our API folder. We'll export a new constant called send password reset function. It's going to be an async function that takes an email, and it'll make a post request to /auth/password/forgot, and we'll send the email in the request body. Now let's go back and import this in. Then let's destructure the response from the mutation. First, we'll grab the mutate function, and we'll rename it to sendPasswordReset. We want to grab isPending, isSuccess, isError, and then the actual error itself if it exists. Now we should be able to uncomment this block of code here, and it won't be complaining anymore. And now we just need to use this success field. So after we hit the submit button and it calls this mutation, if the password reset email was sent successfully, then we want to hide this form because we don't want to allow the user to keep hitting this button and sending emails. So let's add some conditional rendering logic here. We'll go to the top and say, is the mutation successful? So we'll check, is success true? If it's not true, that means they haven't submitted it or it's in an error state. So we're good to display all of this. But if it was successful, meaning they clicked the button and the email was sent, then we want to just display an alert. So we'll add an alert component. We'll set the status to success and give it a border radius of 12. Inside the alert, we'll render an alert icon. And then a message saying email sent, and check your inbox for further instructions. So that looks good. Now we need to add a fragment here because in React we can only have one parent for components. So let's just move this button into our fragment here, and that should clear up all those errors. So now the user will see this form if they haven't submitted the request, or if their request failed, they'll still see the form, but once it was successful, they'll see the alert and they won't be able to submit the form anymore. Now let's update our imports to get rid of all these errors. Then we'll import this component in our app file here. And let's give it a test. We'll go back here and let's go back to the login form, and then we can click Forgot Password here. Here's our reset password form, and I'm going to open up the network tab here. Then I'm going to first put an invalid email. So this user doesn't exist. So this should fail. And we see user not found. And here's our API call. We'll see that error 404 not found. As I was editing this video, I realized that we probably shouldn't return an error message saying user not found, because that will leak data out of our system and anyone will be able to figure out if a particular email is registered in our system. I updated the code in the GitHub repo on the main branch, but essentially I've just taken our service sendPasswordResetEmail and wrapped it in a try-catch block. So any of these app assertions that throw an app error, they will be caught at the bottom here in this catch block. Then we'll log out the error and return an empty object. So when we're searching through our logs, we can search for a send password reset error, and we'll be able to find all the errors that occurred in this service, but the front-end user will never see those. They're just always going to see a success message. So make sure to update your code to reflect this change so that you don't leak any sensitive data. And if I put a valid email like test6@test.com, we'll retry the request and we'll see this success message and our form goes away. We also see that request here in the network, 200 OK, and we see the email being sent. So now let's check resend and verify that the email was delivered. And we see a password reset request. And here's that email. Now, if we go to the plain text version, we have a new link here to /password/reset, and this will be the form that renders and prompts the user for their new password. So we're also going to have logic to validate the expiration date so that if they try to open this page after the expiration date, they won't even be able to submit a request. So let's start building out the page that will handle this password reset form. Let's go back to our app file here, and we'll make a new route. It'll be /password/reset. Then this will be the reset password component. Now let's create this file in the pages directory. We'll add a functional component, and in here, we're going to render a flex component. And inside that, we're going to render a container, and it's going to center the content with our normal style props. Now in here, I want to check, is the link valid? If it is, then I'll render the reset password form. If it's not valid, I just want to display an alert to the user with some error description text and a link to request a new password reset. So let's add a ternary. We'll say link is valid. And if that's true, we'll render a reset password form. And otherwise, we'll just render a vertical stack. We'll set the align to center and give it a spacing of 6 units. Then inside the stack, we'll display an alert with a status of error, as well as the text invalid link. Below the alert, we'll add some text saying the link is either invalid or expired, and then we'll add a link to request a new password reset. And that's going to take the user to /password/forgot. So they'll be able to request a new link. Now let's just import these components in. Now let's write the logic for this link is valid variable. Let's go up to the top, and to determine whether the link is valid, we need to grab these query parameters in the URL. So there's a code property and an exp, short for expiration. So let's grab the code and expiration. We can do that by calling the use search params hook. So we'll say const search params is equal to use search params, and that comes from React Router. So this will give us a URL search params object. And to get the code, we could do const code is equal to search params.get, and then we'll pass in the name of our variable, which is code. Then let's get our expiration. So we'll say const exp is equal to get exp. And let's wrap this call in the number method so that we could just parse the number and not deal with the string value of the expiration, because that's what gets returned by default. Then let's create a variable for the current date. So we'll say const now is equal to date.now. And this will be the UTC millisecond value of the current date. And the expiration is also the UTC millisecond value of the expiration date. So now we can do our check for the link. So we'll say const link is valid, and it's going to be valid if there's a code and there's an expiration date, and the expiration date is greater than the current date. So it expires in the future. You could also write this as now is less than the expiration, but either way, it does the same thing. So our logic looks good here. And now let's start building out this reset password form. This is going to be a separate component because it's going to have its own set of logic and success and error states, and I didn't want to clutter this file up. So we also want to pass the code in here. And now let's create this file. Since this is just a component and not an actual page, I'm not going to put it in the pages directory. I'll create a new folder called components, and I'll put it in there. So we'll call it reset password form. In here, we first want to destructure that code from the props. Then let's add a piece of state for our new password. We'll call it password, and by default, it'll be an empty string. Then let's render our heading. So we'll create a fragment and then a heading component. And for the text content, we'll say change your password. Below that, we'll render a box component. And inside the box, we want to check if an error occurred when we tried to reset the password. If it did, we'll display that, like all of our other error messages. And then we want to do a similar check that we did in this ForgotPassword, where we check if the mutation was a success, then we'll display an alert. Otherwise, we'll display a form. So it's going to work the same way. Let's add a ternary here, and we'll check, was the mutation a success? If it was, then I'm going to output a box with a success alert and the message password updated successfully. I'll also show a link to sign in, and that's going to take them back to the login form so they can log in with their new password. Now, if isSuccess is false, we want to render our form. So here, let's add our stack component. We'll give it a spacing of 4 units. Now let's add our form fields. I'm going to grab the form field from our login component because it's going to be identical. So let's grab this password form control. And we'll paste that in and import these components. For the label, we'll add new password. The value will be the password, and this change function looks good. Instead of calling sign in, we'll call reset user password. We'll pass in the password that's in the local state, and then we'll also pass the verification code. And that's going to be equal to the code passed in to our props. Then let's autofocus this input. And lastly, let's add our submit button. So I'll paste that in. And we have our normal loading and disabled states. And then on click, you want to call reset user password, and we'll pass in the same parameters. And the button will have the content reset password. Now let's create this reset user password mutation. We'll go up to the top, and right below our state here, we'll call use mutation. And we need to give it a mutation function. And we'll call that function ResetPassword. Now we need to create this in our API file. Let's declare a new constant called ResetPassword. It'll be async, and we're going to destructure the parameters this time. We'll destructure the verification code and the new password. And then we want to make a post request to /auth/password/reset, and then we'll pass in the verification code and password. So you could keep these parameters as just data like we did above, but I want to make it more clear to the user when they call ResetPassword, they'll know exactly what parameters they need to pass instead of having to check the API. Now let's import this function back in our form here. And then we'll grab the return values of the mutation. We want to grab the mutate function, and we'll rename it to reset user password. Then we'll grab the pending success and error states. And now that should get rid of all our errors here. We just need to make sure to import these components. And now we still have this ESLint error saying that code is missing in props validation. And I'm just going to disable that ESLint error for now because we're not using prop types. Now if we save this, let's import this form back in our ResetPassword view. And then let's import this ResetPassword page in our app component. And now we should be ready to test out this flow. So we'll go back to our email here, and let's just copy this link here. And in our browser tab, we'll paste it in and then open up the network tab so we could see the request. So I'll minimize this a little bit, and then I'll hit enter. So it loads up our app. And it looks like our expiration date validation was good because we see this form. So now I can type a new password, and I'm just going to type all ones. We'll hit reset password, and then we see that success alert. And here's that successful API response. So now we should be able to log in with that new password. So I'll say test6@test.com, then add a bunch of ones for my password. And it looks like that went through. So that looks good. Now let's test out an invalid expiration date. So I'll copy this link again and paste it in, and then I'm just going to add, or I'm going to remove a few numbers. So this will change the expiration date to be in the past. So I'll try that, and let's get rid of our network throttling. And here we see our error message. So the link is either invalid or expired, and you'll see that we never even made a request to our API because of the conditional rendering. So anytime we refresh, we'll see that it never hits our API. We can also click this link to send a new password reset request, and that all looks good. That wraps up all of our public auth pages, and now we can work on our protected pages, like the user info and the user sessions. So the way that I'm going to do this is we have all of our public routes here, and for all of our protected routes, I'm going to create a parent container. And that parent container is going to authenticate the user. And if the user is valid, then it'll render child routes. And those child routes will be the user page and the user session page and all the other protected pages. That way, all the children pages of our app container, they don't have to check for the user, because if that page is being rendered, it's assumed that the user's already been validated by the container. So let's refactor this code to use an app container. We'll rename this to app container, and inside we want to give it some children. So we'll have an index route, and that'll just be the home component that we made here for now. Next, let's build out this app container. So we're going to do all of our user authentication checks in the container, and if the user is not valid, we'll redirect them to the login component. But if the user is valid, then we'll render the home component. Under components, let's create a new file, and we'll call it app container. And here I'll export an arrow function. And now we need to fetch the user. So that will be another useQuery call. And I'm actually going to wrap that in a custom hook because we're going to need to get the user in a bunch of different places in our app. And I don't want to have to pass in the query options and all the configuration for that query every time. So let's create that custom hook. Under source, we'll create a hooks directory. And inside that, we'll make a file called useauth.js. And in here, we're going to create a wrapper hook for our useQuery. So we'll say const useauth is going to be equal to a function, and it'll take some options, which will be the React query options, and we'll default that to an empty object. Inside the body of the function, we want to call the useQuery hook. So we'll say useQuery, then we'll pass it our config. So our query key is going to be user. And instead of putting in user like this as a string, I want to store this in a constant so that when we invalidate the user cache, we could just bring in that constant and it'll bring us right into this file, and we know which query is associated with that constant. Let's export a constant called auth, and that is going to be equal to the string auth. And now let's pass that in for our query key. Next, we need to create our query function. So let's say query function, and this is going to be getUser. Now let's create this function in our API file. Right below these auth functions, I'll create getUser, and that's going to be an async function to /auth/user. And it's actually going to be just /user. We don't need that auth prefix. Now let's import this back in here. Then let's add some more options. So we want to set the stale time to infinity. And this is basically going to allow us to call useauth anywhere in our app, and it's never going to refetch the user. So it'll fetch the user initially once, and that user will be stored in this query cache under the auth query key. then anytime we call it useAuth, it's just going to return whatever data is in this cache, and it won't refetch the request. That way we get access to the user ID and their name and email and all their data without having to keep remaking the same request. However, it's important to note that if the user session gets removed from the database or their token expires, this data will still be cached in the app state, so they'll be able to see their profile and other views. But that's not a big deal because right when they make another API request for a resource like their posts or comments or whatever it is, the API will always validate the user session. And if it's invalid, it'll return an error response and the app will kick them out to the login page. So I'll keep the stale time to infinity, but you're free to remove that so that it'll fetch the user every time the hook is called. Lastly, let's spread the options that were passed in here if the user passed any overrides. Now we'll get the return value of the use query. So we want to grab the data, and we'll just rename that to user, and then we'll get the rest of the params in this spread operator. Now we just want to return that data. So we'll return the user and the rest of the parameters. Now let's export this hook, and then we'll bring it into our app container. Now we can do const user. It's going to be equal to useAuth. We'll invoke that hook, and then let's also grab the loading state. Now let's add our checks for the loading state. So we'll check if isLoading is true. If that's the case, we'll output a setter component with a little loading spinner. Make sure to import this. Otherwise, if it's not loading, it means either the user was loaded or an error was returned. We'll check, does a user exist? If they do, we'll output a box component with a user menu and the outlet so that child routes can be injected into the outlet. Then we'll add the else case. So if there's no user, then we want to redirect them to the login page. So we'll render a navigate component, which comes from React Router. The path will be to login. We want to replace the current path. And we also want to pass some state to the login form. So if a user tries to open up a page on our app, like /settings, but then when the app loads up, the user's not authenticated, so it kicks them out to the login page. After they log in, we want to redirect them back to the page they were originally trying to view. For example, /settings. So this way, by passing the state through the React Router context, we're able to redirect the user back to the original request. And that just gives them a nicer user experience. Now let's import these components. And we'll comment out the user menu for now. We'll give this a save and then import it back in our app component here. And now if we try to visit the home route, it'll render our app container, try to fetch the user, and then if the user is logged in, we'll render an outlet, which will then render this child index route. And if the user is not logged in, we're going to return the navigation component, which will just redirect them to the login page. So now let's give this a test. We'll go back to our browser here, and I'm going to try to navigate to the home page, and I'll open up this network tab. And you'll see that I got redirected to /login because our user endpoint returned a 401 unauthorized. Now let's try to log in with one of our test users. I'll say test@test.com, and then the password is just a bunch of ones. Now we'll hit sign in, and we'll see that the request to the login endpoint was a 200, but our cookies here, we're getting this error message. Let me do some debugging and figure out why this is happening, and I'll be back in a second. So it turns out that when I copied this sample env, it says our API URL is 127.0.0.1 on port 4004. And that's where we're making this login request. However, when my front end is running, it's on localhost port 5173. And so our browser sees this request as a different origin than localhost. And so that's why it can't set that cookie, because it sees it as two separate sites. And we have the same site attribute set to strict. And so that's basically not allowing it. So in order to fix this, let's go back to our code here. And in our frontend.env file, instead of using this 127 IP address, let's just paste in localhost port 4004. So now this will match the exact domain that our API is running on. And if we just restart our front end server, then we'll retry the login request. So let me refresh this page. We'll try to go to the user endpoint. We see our 401 error, and now let's log in with the test user. Now we'll hit sign in. And that seems to have worked. We see the home page here, and here's our request to the login endpoint. Here are the cookies that were sent in the response. And then when we tried to fetch our user, we got this user data. Now on our client, we can open up the React Query DevTools. And in here, we could see our auth query. And inside here, I'll just make this a little bit bigger. We could see our data here. We have our user ID, our user email, whether they're verified or not, and then a bunch of other query options. We can also refetch this query and tweak the data in here. So this is just a nice little GUI tool for us to use. Now let's clear our cookies and verify that we get redirected to our login route. So in cookies here, we could just hit clear, and that'll get rid of our access token. And if we go back to the network tab and refresh, we'll see we got a 401 unauthorized error, and we do get redirected back to our login component. Now let's sign back in. And then let's start building out our user page with our user menu in the corner. Let's go back to our app file, and we'll uncomment this user menu. Then under components, let's create a new file. We'll call it user menu. In here, we want to return a menu component. So we'll import that from Chakra. We'll pass the isLazy prop so that it only renders the children when the menu is open. And then we'll set the placement to right start. Inside the menu, we'll have a menu button, which will be the trigger for our menu. We'll set the position to absolute, and then we'll add the position properties. Inside the button, we'll just render an avatar with the source set to the hashtag, and that's just going to render the default avatar image. Below the button, I want to render a menu list, and that list will be made up of menu items. And each item is basically going to be a link to another page in our app. So on the profile link, it'll take us to just the home route, and then we'll have a settings link that'll take us to /settings. And lastly, we'll have a sign out or log out button, which is going to call the sign out mutation. First, let's get access to this navigate function. So we could do const navigate is equal to use navigate. And then let's build out our mutation. So we'll call use mutation. Then we need to pass it a mutation function. And down here, we want to log out. So let's create an API function for signing the user out. Right below this login function, we'll create a new one called logout. And then the path will be /auth/logout. This will be a GET request. And we're not going to need any data, so let's just get rid of that. Then let's import this back in our menu here. Then let's add an onSettled event handler. So when this logout function resolves, we want to run a function. The first thing we want to do is clear the entire query client. So it gets rid of all of the data that's stored in the client. We can do that by calling the clear method. And after we've cleared the query client cache, we can navigate the user to the login page. So we'll just call navigate to the login, and then we'll pass replace true. Now let's destructure the mutation function. And we'll rename it to sign out, because that's what we're calling down here. So now if we save this, we should see this user menu after we import it. Let's go back to our browser, and here's that user menu. And we have our profile, our settings, which currently we don't have yet. And then let's test out this logout function. So if I hit logout, then we hit the logout endpoint, and our cookies are cleared here, as you can see, and we're redirected back to the login page. So that looks like it's working. Now let's sign back in, and then we'll build out the rest of the user page. Let's go back to our app routes here, and instead of rendering this home component at the index route, let's render a profile component, and then we'll go and create this file in our pages directory. And here we'll return a functional component. And first we want to grab the current signed in user. So let's grab the user from use auth. And then we'll destructure some user properties. So we want to get the email, the verified property, and also the created app. The reason I'm able to destructure these properties like this and not worry about a loading state is because since we've rendered this profile component, that means the user is logged in, because in our app container, we're trying to fetch the user, and if it's in a loading state, we're going to output this loading spinner, but once the user is loaded in, then we render the rest of our app through this outlet. So by the time that our profile component gets injected here in the outlet, the user has already been loaded in the query cache. So when we call use auth up here, we're just getting the cached user from the query cache. And that's the nice thing about having this app container. All of these children that are rendered in the app container can assume that the user is signed in because our app has already handled the auth check here. Once the user signs out, or if the cache is invalidated, it's going to re-render the component. And if there's no user, we're going to navigate them to the login. So you'll see that in action in a little bit. Let's go back to the profile. And in here, instead of returning a div, we'll return a center component. That's going to have a margin top, and we'll set the flex direction to column. Then we'll add a heading component, and we'll just say my account. And right below that, let's display an alert based on the verified status. So we'll check if the user is not verified, then we'll display this warning alert. Let's make sure to import these components. Below this, we'll display the user's email right here. And right below that, we'll also display the create date like this. So now we'll give this a save and import our profile component back in our app routes. Then let's test it in our browser to make sure we see our user data. Here it is. We see that the user is verified because there's no alert. So let's go into our database and we'll find this test user, and then we'll set the verified flag to false. We'll update the record, and then let's refresh our page, and there we see our alert. So that looks like it's working properly. I'm going to set this user back to being verified. And now let's build out our settings page, because currently it doesn't render anything. Let's go back to our app routes here. Right below our profile route, let's create a new route called settings. And then we'll remove this index prop because this won't be the default path. Instead, it'll be the path to settings. Now let's create the settings page. Under pages, we'll create a file called settings.jsx. And in here, we'll create a functional component. The first thing we want to do is grab all the sessions. So to do that, let's make a custom hook to make that query. Under the hooks folder, we'll create a new file called useSessions. And this will be equal to a function called useSessions. And it's going to get some options in the parameters. These will be the React query options. And inside, we want to call the useQuery hook. Then let's pass it our configuration. So first, for our query key, we want to set that to sessions. And then I'm going to store this in a constant above. We'll just call it sessions. Then let's pass that in the query key. Now we need to give it a query function. We don't have that function yet, so let's go back to our API file. And right below this user call, we'll create another function, and it's going to make a request to /sessions. And then we'll call it GetSessions. Now let's import this back in our hook, and we'll pass it for our query function. Lastly, let's spread all the options that the user may have passed in to override any of these defaults. Now let's grab the return value of this hook call. We'll grab the data, and we're going to rename that to sessions, and then default it to an empty array. Then we'll grab the rest of the parameters. Now we just want to return those properties. So we'll return the sessions and the rest of those query properties. Now let's export this at the bottom, and we should be good to bring it into our settings page. Now we could do const sessions. It's going to be equal to use sessions. And then let's also grab the is pending, is success, and is error. I'm not getting any IntelliSense for these properties, and I think that's because this use query, it's coming from the wrong library. So this should not be from Chakra, it should be from the TanStack query library. So make sure that's the correct import. Now if we go back here, we should get that IntelliSense. Instead of returning this div, let's return a container. And inside that, we'll render a heading. For the text content, we could say my sessions. And now let's handle our loading states. So first we want to check if the query is pending. So we'll say is pending. And if that's true, we'll render a spinner. Then let's check for our error state. So if is error is true, then we're going to render a text component. We'll give it a color of red.400. Then we could say failed to get sessions for our message. Then lastly, let's render our success state. So if it was a success, then we want to render a vertical stack. So we'll say vStack. We'll set the spacing to 3, and then align to flex start. Inside the stack, we want to map over all the sessions. And for each session, we want to output a session card. Then we'll pass that session in through a prop so that we could render all the session info in this card. So let's give this a save. And now we need to create this session card component. Under components, let's create that new file. So we'll call it session card. Then let's get the session from the props. Then we'll get all the properties from our session object. So I'm going to destructure the ID created at the user agent and whether the session is current or not. And now we can display this data down here in our return function. First, we'll render a flex container, and inside that, we'll render a box. Inside the box, we'll just display our created at date, and then we'll also set some helper text to help the user know if the session is current. Below that text, we'll display the user agent of the session, so that would be the device that the user used to log in. And below that, we're going to check if the session is not current, then we'll render this button. And when the user clicks on the button, we're going to delete the session. So we're only going to see this delete icon for sessions that are not the current session, because it probably wouldn't make sense to allow them to delete the current session since that will just log them out. Now I'm going to just import these components really quick. Now let's write our mutation for this delete session function. Instead of doing the mutation in line like we've been doing, I'm going to create a custom hook that'll take an ID property and then return a mutation that will delete that session by ID. Let's create that hook, and we're going to call it useDeleteSession. Let's declare a constant called useDeleteSession, and it'll be a function that takes an ID, and it's going to be our session ID. And inside, we want to call useMutation. So this is just going to be a wrapper hook for calling useMutation. As always, we need to pass it a mutation function. And let's go ahead and create this function. Let's open our API file. And right below this GetSessions function, we'll create DeleteSession. This is going to take an ID. Then let's replace these quotes here with backticks and pass in our ID here. So the path will be /sessions/ID, and it's going to be a delete request. Now let's import this function back in our mutation here. And instead of passing the function as is, we need to pass in the session ID. So I'll create a wrapper arrow function so that we can just pass in the session ID like that. Now let's grab the return values of this mutation. We'll grab the mutate function and the rest of the properties, and then we'll return those. And instead of returning the mutate function, I'm just going to rename it to DeleteSession. So that'll be equal to this mutate function. Now let's export this at the bottom. Let's give this a save and then go back to our session card here. And now we can call that mutation. So we could do const delete session, and we're going to get that from use delete session. Then we'll pass in our ID from above. So now calling this for each session card is going to initialize this mutation function with a session ID that we pass in here. So now when we call delete session, it's going to know to use this ID and call this delete session API function. Now let's grab our isPending property so that we can get rid of this error here. And that's just going to display the button in a loading state when our mutation is running. Let's give this a save, and we'll go back to our settings component, import this in, and then let's also import the settings in our route file here. Now let's refresh our browser page to make sure we can see all of our sessions. So I got logged out, so let me just log back in with our test user. And then we'll go to the settings page, and here are all our sessions. And let's open up the network tab as well. If I try to delete a session, we'll see that it gets removed here in our network call. It was a successful 200. And we see session removed, but it doesn't get removed from our UI. And you'll see if I delete this one, again, it's successful, but nothing changes in our UI. And the reason that's happening is because this data is living in our query cache. So if I open up these Tanstack query dev tools, we see our sessions query right here, and it has a data prop with all of our session items. So when I clicked the delete button and it made that API call, it updated our sessions on the server, but on the client in this query cache, this array was never updated. And therefore, we don't see the changes reflected in our front end here. To fix this, we need to add some extra logic that runs after a successful deletion. So once we call the delete endpoint, On success, we want to get this query data in the query cache and update the array to remove the item that was deleted. So if I just take this second item right here and remove it from our query cache, you'll eventually see that it gets removed from our front end. And now we're left with just one session. Now we can refresh and we'll see all of our sessions again because all of this data comes back from the server and then initializes this query on the client. Let's go back to our delete hook. That's use delete session here. And we need to pass an onSuccess function. So we'll say onSuccess. This will be an arrow function. And inside, we need to update the query client. So all of this data here in the sessions query, the data property. So to get access to this query cache and interact with all the different queries in here, we need to get access to the query client. And we can do that by calling a hook from React query. So we can do const query client is equal to use query client. That comes from React query. And now on this query client, we can call different methods like invalidate queries or prefetch query. But the one we want is set query data. And when we call this, it's going to take a query key as the first parameter. And we want to use our sessions query key because this is the unique key right here that identifies this query. Then the second parameter is an updater function. And this function is going to take the cache or the current data in the query cache, and we need to return the new data that's going to replace the cache data. So let's return the cache.filter. And now we want to filter out the session that was deleted. So we could say for each session, we want to return the sessions that don't match the ID of the one that was passed in here. So this is just going to remove the session object where the ID matches this ID. Now if we give this a save, we should see our front end update as we delete our sessions. So I'm going to refresh here. And when I click this delete icon, we'll see that it got removed. And that was hard to tell because it was at the top. But let me go to the bottom here and remove this one. And you'll see that one was clearly removed. And if I open up this sessions query here, we can see our data here. It's at 9 items. And then when I remove an item, it goes to 8 items. So we know that the data is getting removed from our query cache. Now we don't have to make a separate request to refresh the sessions. We're just modifying this data client side. And that's more efficient, but there could be a case where more sessions are deleted on the server. And since the client isn't refetching the sessions, it's still going to render potentially stale or old data. So it's up to you with how you want to refetch the query cache, and if you even want to update it optimistically like this, you could also just invalidate the query and it'll refetch all of the sessions anytime you delete. If you wanted to do that, then instead of calling set query data, you can just call query client.invalidate queries and then pass it this query key. So now if we save this and we refresh our page here, and we'll open up our network tab. When we delete a session, you'll see that we make a request to delete the session, and then we also make a request for all of the sessions. And this will return that new array, and then this array will replace the data in our query cache here for the sessions key. And this will always pull in the latest sessions because it's making a call to our backend. So it's up to you which way you want to do this, but I'm going to stick with the optimistic update by setting the query data client side. That wraps up all of our pages for the front end. And the last thing we need to implement is the automatic access token refresh process on the client. Currently, if we go back to our front end here, we see that we're logged in and we can navigate through our app. But then if I go and expire my access token, so instead of waiting 15 minutes, I'll just remove this access token cookie right here. Now, if I go back to my settings page, you'll see fail to get sessions. And if we look at the network tab, we see we got a 401 unauthorized error and our error code was invalid access token. And that's fine to display this error message, but ideally we should try to refresh their access token because we still have a valid refresh token. If you look back in the cookies, we don't see the refresh token here, but it is on our browser because it expires in 30 days and it hasn't been 30 days yet. And so we still have that cookie. So ideally, our front end will check for every single error that's thrown when making an API call. And it'll first check, is the status code of 401 unauthorized? And if it is, it's going to check the response body and check that the error code is invalid access token. So if those two things are true, then we should try to hit the /refresh endpoint, and that's going to automatically send our refresh token in the cookie. And if that returns a success, that means a new access token will get set in our cookies on the browser. And after that has successfully finished, then we'll retry this sessions endpoint. And if the sessions load in, then they'll render on the page and the user won't even know that the refresh process has occurred in the background. But if the auth refresh API call fails, then we'll redirect them to the login. The way that we could add this global check for all errors in our API calls is through the Axios interceptors. So let's go back to our Axios client. And in here, you see that we have our error interceptor. This is going to catch all the errors that are thrown when we call our API client. So this would be a great spot to check for the HTTP status code of 401 and that specific error code of invalid access token. So let's go below this line and we'll add a comment saying, try to refresh the access token behind the scenes. Now let's add our if check. So we'll check if the status, our HTTP status code, is equal to 401 or unauthorized. And we want to check if the data.error code is equal to invalid access token. If both of these cases are true, that means we have to try to hit the refresh endpoint. Let's add our try catch block here, because if the refresh endpoint fails and it throws an error, we want to catch the error here and then redirect our user to the login page. We also want to clear out the query cache so that no more data is available on the client side once the user is logged out. To do that, we can just import our query client and then call clear. And this will get rid of all of the queries in our query cache so that the data is no longer accessible on the client side. After we've cleared all of the queries, then we want to navigate back to the login page. So we could call navigate. Then we'll pass in our path to /login. And then as always, we'll pass some state. Then inside that, we're going to pass the redirect URL. Now the problem is we can't call navigate inside of a normal function like this. For us to get access to the navigate function, we'd have to go up here and call use navigate. And we can't call this outside of a React component because we're just in this error interceptor function and we're not inside of a React component. So we're going to get errors if we try to call use navigate. So instead, I'm going to create an instance of the navigate function in memory. And then when our app loads up, I'll call use navigate and then set that function in memory so that we could just import it here and call it throughout our app. Let's get rid of this and we'll go back to our app file here. And here we're going to get that navigate function. So we'll call use navigate. And since we're in a React functional component, we're able to do this. And now we need to set this function in memory. So I'm going to create a separate file that stores our navigate function and then a setter function for setting that value. This will help prevent dependency cycle issues. Under the lib folder, let's create a file called navigation.js. And from here, I'm going to export a variable called navigate. And initially, it's just going to be an empty function. Then right below, I'll export a setter function for setting that variable. So we'll call it setNavigate, and it's going to take in a function as a parameter. And inside, we're just going to set our navigate variable to the function that was passed in. Now let's take this setNavigate function and use it in our app here. So I'll call setNavigate and then pass in our navigate function returned from the hook. Next, let's go back to our client here, and we could just import the navigate function from our navigation file. And now this should all work as if we were just using the regular navigate function. Now there's probably a better way to do this, but it seems to work for me, and so I'm just going to stick with it for now. Now let's add the contents for our try block. So in here, we want to try to hit the auth refresh endpoint. To do that, I can use our API instance here. So we can call await, and then we'll make a GET request to /auth/refresh. If this returns a successful response, that means a new access token is set in our cookies, which means we should be good to retry the original request that threw this error. To retry the original request, we need to get access to the request configuration. Once we have that config object, we could just return the results of our API client, and instead of attaching a get method or a post method, we want to make it dynamic so that whatever the request, the original request was, whether it's get or post, we just want to call that method. So we don't want to hard code it here. To do that, let's just invoke our client, and then we'll pass in our config. To get access to the config, let's destructure our config from the error. So we could go above and do const config, and that's going to come from our error that was caught here. Then we could also move this response to be destructured off of the error. Then we'll default it to an empty object, and that cleans things up a little bit. Now, currently, this solution may work for us, but there are some cases where it will trigger an infinite loop. For example, if we try to make a request to get our sessions and our access token is expired, we'll receive a status 401 and the error code will be invalid access token. Then we'll try to refresh our token, and let's say this returns a new access token, so we retry the original request. If for some reason that access token was found to be invalid, or when we retried the original request, that response also returned a 401 with this error code, then it's going to rerun our error interceptor because we've defined this to run on all the errors that happen on our client. So it'll make it back in this if block and try to refresh our auth token, then retry the original request and potentially go in this infinite loop. So because we've defined this error interceptor to happen on all errors on our API client, there's a chance that we could write some buggy code which will cause infinite loops on the client. And to avoid that, we can just create a separate client that has no error interceptors so that when we call the refresh endpoint here and retry the original request, we can use that separate client and we won't have to worry about making it back into this if check because that other client won't have any of this logic. It's not going to even have an error interceptor. So that'll just be an extra safe way to prevent any infinite loops from happening. Let's create that separate client. I'll go right below our options here, and I'll call it token refresh client because it'll be responsible for refreshing the token and then retrying the original request. And that's it. We're not going to use it for any other purpose. This will be equal to axios.create, and then we'll pass in our normal options. Then let's set a response interceptor because we want this data when we call the client down here. If this returns a success, meaning that the token was refreshed, and we have the data available, we want this data to be formatted the same way that our normal API client is formatted. And for that, we need to use this function. So I'm just going to copy this code here, and we'll paste it right below. And then we'll replace this API with token refresh client. And let me rename this to token refresh client. And this time we're not going to pass an error interceptor. So we're only going to have the successful promise fulfilled interceptor. That way it's never going to run any of this logic and it won't ever even do this check. Now let's update the name down here. And let's also replace this call to use our token refresh client. Now let's refactor our login page to use this state that we pass it when we redirect the user. That way, when the user gets signed out, after they log back in again, they'll get taken to the previous page that they were viewing before getting signed out. So let's open up our login page. And you see here on this mutation, after they successfully log in, we navigate them to the home route. And this is a static string, so it's not going to take into account which page they were previously viewing. In order to get access to the navigation state here, we could just call a hook. Let's go to the top here and do const location, and that's going to be equal to use location. That comes from React Router. And this is going to return a location object, and on the location, it's going to have our state. Let's grab the redirect URL. That's going to be equal to the location and then the state property. And if that state exists, we want to grab the redirect URL. And if that doesn't exist, we'll default it to the home route. Now let's just use this redirect URL instead of the static path. And now anytime that the user gets logged out and a redirect URL is passed in the state, they should get navigated back to the original page before they were signed out here. So let's give this a save and we should be able to test this out in our browser. We'll go back to the login and open up the network on the side here. Now I'm going to sign in with my test user. We have our sessions here, and I'm going to go and clear all of our cookies, or just the access token rather, so we should still have our refresh token. And when I try to refresh, we should get an auth error, and then our client will refresh the token and retry our sessions call. So I'll refresh, and you see we originally got an error here, 401. Then that triggered our client to make a call to the refresh endpoint. This response set a new access token in our cookie, and this cookie was used to make another call to the user endpoint and the sessions endpoint. This returned all of our sessions, and we see those in the browser. And from the user's point of view, they had no idea that the refresh flow even took place. Now let's test our redirect functionality. So if I clear our cookies again, I'll clear both access and refresh token. Now, when we try to refresh these sessions, it will fail, and we should get redirected to the login page. So I'll refresh now, and you see we get redirected, and when we inspect the network, we first received a 401 unauthorized, so that prompted a refresh request, and this returned a 401 error as well. Then we were redirected to the login page. Now if I sign in, we should get taken back to our sessions page because that was the page that we were viewing before getting logged out. So let's give that a test. I'll sign in, and you see we get taken back to our sessions, and all of these calls were successful. Now I want to test one last thing. So say our tokens are valid, and I'm able to navigate around the app and refresh, but then the sessions get cleared from our database. So I'll remove these directly in the database. We'll go to sessions and just clear all of these documents. Now, from the client's point of view, they think they're still authorized because they have valid tokens that were just set in their cookies. So the user will be able to use our app freely for the duration of our access token, so 15 minutes. Even though we cleared the sessions from our database, the access token is still valid, and that's kind of the drawback behind JWTs. is that if the token gets stolen, it's able to be used for as long as it's available. And that's why you usually want to have short-lived access tokens so that even if they get stolen, they can only be used for a short amount of time. Instead of waiting 15 minutes, I'm just going to clear the access token from my cookies here. And I should still have a valid refresh token stored because it hasn't been 30 days yet, so that will still be in my cookies. Now, when I go to the profile page and back to the sessions, when it makes a request to the refresh endpoint, it should error out as well because I just removed all of the sessions from our database. Let's test that out, and you see we get redirected. Here's that request for the sessions. This returned an error because I had no access token. Then when I hit the refresh endpoint, I sent my refresh token in the cookies, and you could see that here in the request cookies. This was a valid token, but our sessions were removed from the database. So that invalidated our user here, and they were redirected to the login page. We should also verify that our queries were actually cleared from our query client. And we see that we don't have our auth query or our sessions query anywhere in this query cache. So that looks like it's working properly. That wraps it up for this video. Thank you guys so much for watching. Leave a like if you enjoyed and subscribe if you haven't already. It would help me out a ton. Let me know in the comments if you have any feedback or what you guys want to see next, and I'll see you in the next one.